Hello everybody, Zachary Fruling, aka Cozy Azeroth here. I'm getting ready to work on our TI Extended Basic Socrates game about the life and conversations of Socrates set in ancient Athens and programmed in TI Extended Basic for the Texas Instruments TI-99 for a home computer. A little retro programming and a little retro game development. I'm just getting set up, so give me a second. I need to get into Discord. So Dylan, my friend and collaboration partner, can follow along with me visually, so give me a second. I need to share my screen inside Discord. Speaking of which, you're welcome to join my Discord server if anyone's watching. The link is in my Twitch description. Let's see, entire screen, share screen. There we go. Okay. Dylan, is that you? Are you there? I think I saw you. Hey, how you doing?
Doing good. How are you?
Good. Kind of a lazy morning. Just got out of the shower about 20 minutes ago, so just getting in the zone, you know. Yeah, a nice mellow Sunday. Did some couple hours of casual World of Warcraft earlier.
Fun.
Yeah. I was just getting set up here. Got our Trello board. Got Classic 99 queued up. Got our code here. I think everything we need, yeah. Our TI Extended Basic Manual, our variables list, our design document, our map. It's amazing how many resources we've created for such a simple game, you know.
It really is.
And you made use of. Well, let's look at our Trello board. I know the problem with the input routine for why the enter key and other keys I discovered thanks to a tip from our new almost friend, not yet because we haven't really met him, Brad Snyder, who's going to help us with compiling, and I've chatted with a little bit on Atari Age. He pointed out that other keys would likely cause right-hand movement, because what I found was that if we skip the joystick input, but we press any key other than the keys we selected, we weren't looping back to line 100, we were actually moving ahead to the movement routine, and when both H and V are 0, it actually, there's the little equation I wrote doesn't handle that. It actually just defaults to right-hand movement, which is what was happening there. So I want to try to rewrite that. I think I can probably make it a little more consolidated just a little bit, make it a little more efficient while we're at it, now that I've looked at it a little bit. So I'd like to spend a little time doing that. I think we should fix this problem with the exclamation mark going over Socrates. I don't think that'll take very long, and I think that'll add a nice little bit of dimensionality to it, because when Socrates is behind the exclamation mark, it'll almost look like he's behind it three-dimensionally, even though it's a two-dimensional game. I think that'll look really cool.
Same. Yeah, like it's floating.
Do we want to keep adjusting the colors, or are we pretty happy with the colors for now?
I think we're pretty happy with them now.
Okay, let's move that to done. And title screen music we want to work on if we get that far today. I think we will, because I don't think either of these will take very long. Let's go ahead and paste the code that we have in. Oh, you can see here, so I actually added one line. I messed around with it a little bit late one night. So what was happening here is that we were getting the input, and then we have, if there's no input whatsoever, we just loop back to line 100. And maybe we don't even need to do that. It might just be we loop to line 110. But we want to keep checking to see if we're on the final screen. This line 100 is the escape clause that gets us to the very, very end game, when certain conditions are met. But then we were checking for keyboard input, and if none of these inputs are met, H and V equals 0, and if you come down here and see what happens, if H and V are 0, if H is 0, then we have 0 plus 4 is 4 divided by 4, so M equals 1. And then same thing here, M and N equal 1. If you plug that in, N equals 1, M equals 1. N times 1 times 3 is 3, plus 1 is 2, so if S is greater than 5, so let's see, D equals 5, so 1, 2, 3, 4, 5, we're going down to line 1100, which is right-hand movement. So that's what was happening there. And I think we can probably improve all of this. In fact, I jotted down some notes that I'm going to try to consult on my phone while we're doing this. So I think what I want to start by doing is making a copy of this, commenting one version out, and try to do a total new take on this. So I think I can probably make it a little more efficient. Even if we cut 1 or 2 lines off, it would be more responsive, you know? So line 100 we're going to leave as is. I guess part of my initial idea is to separate out the joystick input and the keyboard input. Right now they're being combined into a single subroutine down here. Because right now, you know, you can only move one thing at a time, so it almost doesn't make sense to me to grab both inputs. Like, if we want to prioritize the keyboard, which is what we've been doing, over the joystick, we should just look for keyboard input, see if there's a keyboard input, and if there is, do the thing. And if there isn't, then move on to the joystick input, do the thing, and then if neither of those, then circle back. That's my idea. I don't know if it'll be more efficient or not. That's why I wanted to make a copy and fart around with it, you know.
Yeah.
So let's try it. I'm just gonna
go.
So let's try capitalization call key, and we can always consolidate and make subroutines for anything we're reusing here. So so call key. We were doing 0, K, S. 0 meaning full keyboard, K is the keyboard ASCII code of the key press, and S is the status, whether a key is pressed or not. Or I think there's 3 different versions. There's like this no key, the same key as last time, or a different key as last time. Okay, so now I think we can do something like actually, let me consult my notes because I had an idea. Now I don't have it handy. It's probably I think about these things late at night, you know. We're just sitting on the toilet, whatever. In the shower. Okay. Let me think. So we want to define H and V in terms of K. And I think there's a great way. Yeah, I think this will work. There's a way to combine the basically consolidate the upper and lowercase, basically convert the uppercase into lowercase or lowercase into uppercase. So I think what I'm going to try to do is something like this. K2 equals 32 times, oh no, sorry, K minus, there we go, missed something. I was like, something doesn't make sense. 32 times K greater than 96. Okay, I know this is going to be, I'll explain this in a minute here. Let me write this down and see if it actually makes sense. Oops, H equals 4, because it has to be 4, 0, or negative 4. 4 times K2 equals 68 minus K2 equals 65. And V equals 4 times, I'll explain this here in a second and see if you can see what I'm going for here. K2 equals 87 minus K2 equals 83. Boom. Okay. So let's see what we got so far. Maybe I don't even need the K2, it could just be K. So what's happening here is this little equation here is going to take any of the key codes over 96 and reduce them down to, in other words, these uppercase, lowercase letters, and convert them into uppercase letters. So if it's 119, it's going to default down to 87 by subtracting 32. And because this is just going to evaluate either k is greater than 96 or it's not. If it's greater than 96, it's going to say subtract 32 times that. It's either 1 or 0. So if it's 0, it's not going to subtract anything. If it's greater than 96, it's going to subtract 32. So this will take all the lowercase and convert them into uppercase.
Okay.
Yeah, so that's handy. So no weird if-then. This is quite a bit simpler. Even though there's more math, the computer handles math pretty quickly. Okay, and then we need H and V from that. So same thing. Now I got to kind of reason through this. So let's say, let's see, this is going horizontally to the right. So let's say K, the key press, the ASCII code for the key press is 68. This will evaluate to 1. It's either 1 or 0, right? K2 is either equal to 68 or it's not. Minus, this will evaluate to 0 because 65 isn't pressed if 68 is being pressed. So 1 minus 0 is 1. 4 times 1 is 4. That's what we want. H equals 4. And let's say it's the other way around. Let's say we're going to the left, so 65 is being pressed, which is A. K2 does not equal 68, so that'll be 0. 65 is being pressed, that'll be 1. 0 minus 1 is negative 1. 4 times negative 1 is negative 4. Boom, and that's exactly what we want. Following along?
Yeah, it just clicked.
Yeah. So same thing over here. Let's check our work. So let's say key 87 is being pressed, which is going vertically upward, right? V equals 4, so 87. So if 87 is being pressed, we're going up. So this will be 1, this will be 0. 1 minus 0 is 0. 4 times 1 is 4, and that's what we want. Vertical equals 4. And if down is being pressed, which is right here, V equals negative 4, so key 83. If 83 is being pressed, then this will be 0. K2 equals 87 will be 0. Minus 83, that'll be, so 0 minus 1. 4 times negative 1 is negative 4. For V, and that's what we want. So that should work perfectly. All that. So now we get H and V calculated in a single line. Boom. Better. Assuming that it works this way in Extended Basic like it does in regular Basic. In fact, we could check it real quick. Let's just check to see if this method works. So let's say let's let A equal 13. Then we say 20 print A equals 5. So this should default to 0 because A does not equal 5, and it does. See, boom. But if we say 20 print A equals 13. Now it's true, it'll evaluate that as 1. Oh, why did it do negative 1? That's weird. Why are we getting negative 1?
Yeah. I would have expected 1 or 13.
No, I would have expected 1 because A equals 13. That's weird. Why are we getting negative 1? Let's go look at. That's weird. That's not what I expected. Let's go look at logical expressions here. Okay, here's something similar. Let's see what's happening. A equals 2 is less than 5, so that should be true since A equal to -1. Okay, that's what we're experiencing. As it is true that 2 is less than 5. So -1 is true. A relational expression has a value of -1 if it is true, and a value of 0 if it is false. Okay, so that's going to change our equation here just a little bit. We need to flip these around then, right? If we do 65 and 68 and 83 here and 87 here, now, okay, 65 is going left. So if we hit 65, that's true, and 68 is false. So -1 minus 0, 4 times -1. Okay, that's going to the left now. Okay, yeah, all we had to do was flip those around. All right,
Nice.
perfect. Yeah.
So cool.
So let's see. I think what we want to do, we need like an if-then statement. If S does not equal 0, then do all of this and go to line 200. That's the entire call key routine now.
Wow.
120. Otherwise, if S is 0, it'll skip ahead, and then it'll check for joystick input, called joist. And we got to remember what format we used here, and we may want to put these into subroutines, but maybe not. 6900 it was. 1 HV. 1, H, so joystick number 1, horizontal and vertical. Let's see, if H equals 0 and V equals 0, then we want to loop back to line 100. Else, we just want to go to 200. Right? Because we'll have the values for H and V now. Is it really that simple?
I think that's everything.
Yeah, so we check for the key routine. If the status is 0, in other words, if it's not equal to 0, in other words, if there's a key press. Oh, wait a minute. Oh, yeah, this is, right. I'm not. We may need a little escape clause here, like if any other key is pressed, then we'll circle back up to line 100 or move on. But maybe that's okay. No. We do need something like that. So let me think about what will happen here. So let's say any other key is pressed. Let's say key number 90 is pressed, whatever that is. So this will be false. This will be false. 0 minus 0 is 0. 4 times 0. Okay, yeah. So we need... we might need one more line here. If H equals 0 and V equals 0. Then 120. No, 130. Else 200. Actually, this is too complicated. We can do something like if H if H is not equal to 0 and V is not equal to 0, then 200. That's all. And then otherwise it'll just move on to the next line. Okay, let's talk this through. We get the key input. If the status is 0, in other words, if there's no key press, then we do this weird little calculation. Or if there is a key press, then we convert any lowercase to uppercase. Then we calculate H and V based on these little formulas. Then we say if H and V are 0, because if any other key is pressed, they're going to be 0. Then if they're not equal to 0, H and V are not equal to 0, then we skip ahead to 200 and start our movement. In other words, if any one of these 4 keys is pressed, 4 letters, uppercase or lowercase, then we go ahead and do the movement. And if that's not the case, we then check for joystick input. And if H and V are 0, then we know we haven't moved at all and we go back to line 100. Otherwise, we skip ahead to line 200 and do the movement. I think we got 6 lines down into 4.
Yeah, I agree.
So let's delete this and see if that did the trick.
Yeah.
That would be great.
Would be great. I think it will.
I think
that everything makes sense.
But yeah, it's amazing we stared at that so long and we managed to get this far into it without realizing that we weren't circling back to line equals 100 for other inputs besides our 4 keys. So
yeah,
it's all right. That's why you play test, right? You got to check everything.
really. Yeah, to notice stuff like that. Well, there's so many things being built.
Mm-hmm.
So many different dimensions to focus on.
I hope this works because certainly would get a few tokens back.
I feel like it's going to. Such a cool idea. I had not even kind of considered that. I feel like it's so cool.
Yeah, it's amazing now. You stare at it long enough, you go, I got a better way of doing this. Yeah.
Yeah.
Those if-then statements there's often ways to get around the if-then statements. All we need is those values, H and V. The if-then statements are just a way of getting to those H and V values. All right. It might yell at me and go, syntax error. Who knows? Oh, I didn't check the starting area. That's okay. Oh, we're at 0, 0. Okay, cool. Amazing how slow it feels now that we've been playing it faster. Okay, up, down, left, right. Uh-oh. Oh no, it's working okay. Oh, weird. It's almost like it's... Let me speed it up a little bit. Oh, why are we still moving?
Ah.
Okay, hold on. We're still moving. What is the problem? Why would it do that? Why would it keep going? Let me do this. S equals 0, then 130. Else, do this.
Yeah, that makes sense.
I'm going to speed up our throttling here so it's a little easier to test. I think that's it. I think that worked. Oh, except the keyboard's not working. Joystick's working, but keyboard is not.
Oh, the keyboard's not working?
Nope, joystick is working.
Huh.
Okay, why isn't that working? Feels pretty smooth. Like, almost, it's smoother, it's definitely faster. There's fewer lines for it to go through. But why is this bit not working? Call key 0KS. If S is 0, if no key is pressed, then go ahead to 130 and check for joystick input. Otherwise, might not even need K2 here, it could be K. K minus 32 times K. I don't see any problem. Oh, this should be or. Either one is not equal to 0, then 200.
Oh.
That's it.
Yeah, that totally makes sense.
That's probably what was hanging it up. They're never, you can't press more than one key at a time.
Yeah.
Oh, no, still not working though. Sure. Okay, well, it's working with caps lock.
Oh, it is?
Yeah, so
Oh,
it doesn't like, that tells me it doesn't like this. Why wouldn't it like this? Let's just double check our manual here real quick, the key codes. Actually, we have them right here. It was working fine. Oh, it might have to do. I might have to do. I think in order to use the joysticks, you have to have caps lock on or off. So it might be. It might be related to that. I don't remember. But let's see. Is it working with the caps lock on? It's working as expected. Up, down, left, right.
If we comment out the new stuff you wrote, uncomment the other stuff, could we do it with the caps lock off? Or had we not ever tested that before?
I don't know if we'd ever tested it. I guess.
Was it even working?
Yeah, I mean, well, so let's comment this out.
Yeah, let's see if
And
that's
paste.
working. Yeah.
Oop. That's a good question. I mean, maybe
Yeah,
we'll
paste the lower section too. It's not commented out. You gotta do both those chunks, right?
what
Or
both
else
where?
because if you don't, that section below too, because that's pasted in right now.
Oh, we're just gonna rewrite over it. We paste this in, it's gonna rewrite over these lines.
Oh, that's right. That is how it works. Okay,
Yeah.
You're right.
Let's see. Okay, so this is joystick, keyboard. Let's do the caps lock, and okay, so it is working in both cases in the first instance.
Okay, well that's good to know.
It is. So okay, let's comment this back out. Where did I go wrong? Pretty close, though.
Yeah.
I don't know if we need K2. I think it just could be K, because you can... You'll take K and then just define it in terms of itself. So let's get rid of that. I think that's fine. It's fun how you kind of try something and whittle it down, you know? Actually, we need to paste the whole thing in because we have fewer lines here, so let's just paste the whole thing in. There's a couple folks have recommended a code editor called TI-99 that was built just for a TI extended basic. And it basically gives you structured programming without line numbers. And so it'd be a little more like programming in Pico 8. And then it can actually export it right into Classic 99 directly and run it for you automatically. So, but you know, we're this far in. I don't want to change gears mid project, but if we do another TI extended basic program, maybe we should play with that. Might be easier.
Okay.
Faster, I don't really care about faster. Gives us a chance to chit chat between takes here, so to speak.
Mm-hmm.
I care about efficiency a little less as I get older.
Yeah, I think that's a good of
I've been a
that.
slave to efficiency my whole working life.
Oh yeah. It's the way they like to drive us.
It sure is. Truth, my friend, truth. Okay, joystick's fine. Okay, I think what I want to do, in the interest of testing this, let's do display 3, 3, or display at 3, 3. H and V. Let's see what we're getting when we use keyboard. Sound good?
Yeah.
Oop. debugging code. Okay. 0, 0, 0, 0. Caps lock. Oop. Okay, that's working as expected. 4, negative 4, 4, negative 4. Why are we getting 0? Okay, I want to check a couple other things here. Let's do the, in addition to H and V, let's do the value for K. See what we're getting. I like how easy it is to write a little debugging routine right there in the program, you know. Okay, 151. Oh, 151, 147. Okay, this is a problem. That's why it's not working. Caps lock. Okay, but if we put caps lock on, we're getting input, so that's good. We're just not getting, it's not evaluating K correctly. Why not? Why not? So let's just check our work here. Let's say we hit up, which is W at 151. Why are we getting 151?
Oh yeah, that's not even on there.
Well, it's giving us K, so it's giving us the result of this calculation.
Yeah, why is it?
Well, okay, so oh, because yeah, I know what. Because this needs to be. we forgot that this evaluates to the true evaluates to -1, not to 1. So it's adding instead of subtracting.
Oh yeah, the true means negative.
So if we add. Is that all there is to it? I might fix it. We need to add instead of subtract there. Up, down, left, right, caps lock. Up, down, left, right. Got it.
Nice. Yeah, it's weird that true equals -1.
I know. Well, that's news to me. I don't know why. I think that might be different from regular TI basic. In fact, I'm so curious. I want to check right now. TI basic. So 10 A equals 13. We had 20 print A equals 13. Nope, same thing. -1. Yeah, I guess we just misunderstood. Okay, well, good. Now we know, right?
Yeah.
I think that solved it.
Yeah, it looked like it.
Let's go back into notice here. Watch this. 30 go to 30 run. In regular TI Basic, the screen changes to light green when you run the program. It does not do that in Extended Basic. Yeah.
Yeah, I was wondering why that was happening.
Yeah, so when I was a kid, this is the default look for your in an active program. You know, if you don't do anything else with the colors, because I didn't have Extended Basic, I didn't have the cartridge. Yep.
Cool.
It's part of the visual language of the TI. You know, the light green means your program is running.
Oh, I love that. I love green.
Okay, Extended Basic. I think we solved it.
Same.
Let's just
Yeah, that could be working properly.
let's paste the whole thing in again. And let's just check it real quick, and then we'll get rid of the debugging code, paste that in, and check it one more time. Just to be totally anal retentive about this before I delete those lines that were working. In fact, I think I'll paste, just like we've done a couple times, just for safekeeping. I think I'll paste this into our design document.
Yeah, that's a good idea.
just in case. You know, although it is storing backup versions. You know, the nice thing about using my OneDrive is it does store previous versions of all these. Every time we make a change, it stores a previous version of the file. So we're in good territory no matter what. But, and I want to check it without the acceleration on, just to see what it's like, see if it's sped it up at all, you know, and make sure everything else is working as well. Let's run this though. Okay, this is joystick. I'm using joystick. I can go diagonally with joystick. Keyboard, up, down, left, right. I can't go diagonal. If I try to go diagonal, it just kind of picks a direction based on whatever the most recent key press was, which is fine. Caps lock, up, down, left, right, no problem. Feels good. You know, it's funny. The keyboard feels slower because you can't go diagonal. When you go diagonal, it actually feels faster, even though it's because it is. You know, because if you want to do this up. You know, you have to go. So yeah, it actually joystick feels a lot faster, even though it's not really. You know.
It does. It feels so much faster.
Well, actually, kind of let me check here. If I'm going to the right, okay, that was joystick. Now this is keyboard. It's actually a hair slower because it has to do all the math. Joystick, it doesn't have to do that, but keyboard it does. So that's okay. Just is what it is.
What it is.
Alright, it seems like we haven't broken anything. Let's turn the accelerator off.
Yeah.
Okay. Oh man, it's still painfully slow.
So much slower for playing with the throttled version.
Joystick is definitely faster for sure. Let's get off the screen with the dialogue.
Yeah.
Oh, I gotta go this way. Can't go around that. Or can't go through that, I mean. I mean, it feels about as expected. I'm not sure if it's any faster. It might even be a tad slower. But we certainly got... What's that?
I said, yeah, I can't tell if it's faster.
I mean, if we really want to... I want to see if we actually saved any memory, because we have a lot of tokens in this math here. Before we commit to it, you know. Let's paste this in. Oh yeah, we definitely saved some tokens, for sure. Okay, I think I'm convinced that this is the way to go. How about you?
Yeah, same. And we could take out the display ad thing.
Yeah, in fact, the display ad is actually slowing it down a little bit as well. Now that I think about it. There's no way to kind of combine these lines because we got the same kind of overlapping if-then statement problem. Although, you know, we could... Well, yeah, I think this is just the way to go. Yep, that's as tight as it's going to get.
Yeah.
New. But hey, look at us saving tokens.
Yeah, that was a good one. I didn't see that one coming.
Yeah, it's amazing how you just keep hammering away at it with a little bit of insight. Something I didn't think of originally, but there was a better way to do it, or at least a more compact way to do it. It may not be faster. It may actually be slowing it down a little bit because of the math, maybe. But it's got to be fast. It doesn't have to go through 6 lines. It only has 3 lines, and so if there's keyboard, it just jumps right to the movement. You don't even have to check for the joystick input. It's got to be better.
Definitely.
I think maybe the display out was slowing down the keyboard a little bit. We'll run it here in a second. I'm having so much fun working on these games together, Dylan.
Same.
Really is one of the highlights of my week for sure.
Same.
I wish we could do this full time, you know. We just gotta. We'll get there. We'll figure out some games we can sell and start getting some income coming in.
Mm-hmm.
And then once we do, we'll have to, figure out how to do an LLC so we can split it and not have it build either one, not have it. Because right now, if we, which is fine for the beginning, because if we put it on itch and we get a little money coming, it's not going to be much money, but it'll have to be in one of our names, and then we'll just have to give each other the money. But then we have to worry about taxes and stuff. So if we get a significant amount of money, we'll have to worry about putting it in an LLC so we can, separate it from our personal taxes and whatnot. But you don't want to do that so you get a significant amount of money coming in.
Yeah, exactly.
Okay, let's see what we're doing size-wise. 26, pretty good. I made a mistake before of starting an LLC before you had actual money coming in, and just cost hundreds of dollars and never made more than $20. It was not worth it.
Same.
Not worth it. You tried it before too?
Yeah.
I think everyone goes through that apparently. Like we have the next great thing. Let's start an LLC. Like wait till you get some money coming in, then do it.
Yeah. I thought that's what I had to do first.
Yeah, likewise.
License and get an LLC and go do all this stuff, but yeah, didn't really have a successful thing running yet. It's been a bunch of exactly.
Okay, so it does feel a little faster without the display. Not by much, but a little bit. It's noticeable.
Mm-hmm.
And so let's turn the accelerator on. Up, down. Well, it's working exactly as expected. Now I'm using joystick. I'm going to hit caps lock. Yep, caps lock. Keyboard is working exactly as expected. All right, I think we solved it.
Nice.
Let's move that to done.
Let's do it.
Done. All right, exclamation mark goes over Socrates. Okay, so now I'm going to get a piece of paper out here to take notes because I need to remember. So right now, I'll just make, I guess I can do it on screen, but I guess paper's fine. Old, new. All right, so Socrates right now is sprite number 1. And exclamation mark are number 8, 9, and 10. So the problem is that we want the exclamation marks to go over Socrates. So if we change Socrates as, and actually it might behoove us to, it might actually work a little faster if we use I'm not 100% sure on this, but if we get all the sprite numbers to a lower number, they might actually go fast. What I don't know is if it has to go through all the registers in order to grab the right sprite number. It might be totally in my head. But let's get it working first, and then I can research that for next time. So why don't we do exclamation marks 1, 2, and 3. And Socrates number 4.
Yeah, that would be perfect. What are our other ones?
21 through 28.
Oh, nice.
Okay.
That's perfect.
All right, so we just need to go slow and steady here and make sure we catch all instances of those sprites. Okay. Sprite. These are fine. Okay, here's where we're going to start screwing things up. So these should be... Well, actually, let's go up to the very top, make sure I'm catching all of them. Now let's get caps lock. Okay. These are our exclamation marks. So, 1. Why do we do them this way? Why is it 8, 9? Huh.
I don't know. We should maybe follow the same pattern though.
Yeah, let's do 1, 2, 3.
Yeah.
Okay. Delete sprite 1, 2, and 3. Okay, call sprite. This will now be number 4
Yeah.
at Socrates.
Yeah.
Is that literally all?
There's a few, but I couldn't read them too fast. Oh, that's delete all. Oh, the other one's probably delete all too, actually.
Mm-hmm.
The other one I saw.
Yeah, because
yeah,
there it's all.
This is called just down towards
Yeah,
the
well, it's a subroutine.
Ah, that's why. That's right. I remember that now.
That's it.
Yeah.
Save. Let's make sure it works. And check it out.
Check it out.
And then I thought we could work on the music a little bit.
Yeah, that'd be fun.
Yeah, I figure we'll just dabble in another program. We won't mess with our program here. We'll just start a new document and see what we can come up with, and then we can get something we're happy with. We can try to paste it in and hopefully whittle it down enough where it fits. But it's gonna have to be pretty small. So
yeah.
But I like the melody you came up with. Did you mess around with it anymore?
Not really.
Okay.
I messed with it a little bit when we first got off the meeting, and then I just didn't find myself back at the piano.
That's okay. Do you know what notes they are at least?
I think so. Yeah, because I was C, D, E, F, and G.
Just in the key of...
C,
Cool. Just in the key of C. Perfect.
Yeah.
We could even put it in a different key just to make it sound a little different.
Yeah. Yeah, I think I know how it goes. I can't remember it.
Well, we actually got 2 bytes back because we're using the sprite numbers were shorter. We got rid of sprite number 8, not sprite number 10, so we got 2 bytes back.
Nice.
All right. Hopefully this works. Should. That looks normal. Oh, that didn't work though. Yeah, I don't know what happened there. Ooh, what did I screw up?
Whoa.
Okay, I screwed something up.
Yeah. Something about changing Socrates to 4 or something?
I'm really confused what happened there.
Does that really change the move?
Yeah, I don't know why.
Very bad value in 6600.
Let's go. Yeah, let's at least go look at that and see what 6600. Call sprite number 4.
Socrates.
What did I mess up? All right. Well, let's go back. Let's revert it. 1, 2, 3. This is 8.
9, 10, 8. Yeah.
Did I accidentally delete? 8, 9, 10. Hold on. Just skimming. I'm looking to see if I accidentally deleted something.
I didn't see you do that.
I didn't either. Sprite number 1. Okay, well, it was with the movement routine, so let's check out the movement routines.
Opposition number 1. Is that a sprite?
Oh, yeah. That's the problem.
That should be 4.
That should be 4. That's the problem.
And you look up number 1. See if there's another number 1 anywhere.
Yes. Okay, but yeah, that's the problem. I'm certain of it. Okay, so this should be number 4. Let's go back and change these back. This is 1, 2, 3. Right?
Yeah.
This should be number 1, 2, 3. That looks good.
Yep.
This should be sprite number 4. Okay, now let's check position. That should be number 4. We just fixed that. Is that the only position? Those are okay. That's it. Okay, that'll probably fix it. Caught me totally by surprise. What the hell is going on?
That's confused me so much when you just went all the way across the screen.
Well, because it grabbed the position from the wrong sprite and zapped you over to the wherever that was.
Yeah.
That's funny. I'm always like, oh my god, did I just blow up our game? Oh my god.
Yeah, what is going on?
Yeah, I liked. I only played the melody you sent me a couple times. The timing needs to be worked out. I could tell you were fumbling around with the time a little bit because it seemed like there was a phrase that kind of repeated 3 times with variations. The first time had 5 notes, and the second 2 times had 6 notes. And so I wasn't clear exactly what the intention was with the timing. So we'll have to work that out, but we'll figure it out.
Yeah, it looped well, but I wasn't sure where it starts and stopped to like yeah, one video of it and send it.
Okay, here we go. And we can go. Oh. Well, it's funny because it'll only come up in one spot. Because we can't get close enough to it where it becomes an issue until. Let's go do another one. Because it's not like if we get within 2 characters, we trigger the dialogue. So the only time it will come up is when we're coming from this direction, right here.
Yep. Oh, nice. It works now.
But I like it better, don't you?
Yes.
And
Yes, I like it. I think it makes more sense.
yeah, and it works just fine. All right, there we go. Boom.
Nice.
Let's move that to done. That was super simple. All right, time for music.
Let's do it.
All right, so let me save this. All right, let's open a new. Well, let me play your melody and see. I gotta find your message here. Turn my volume up on my phone. Let's see. So what's that first note? Because it starts do 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 do.
I couldn't really hear it through there, but I think it started on G, but it could also start with C because I ended it with a double C, but it could have started with a C also. I wasn't sure. Like I said, I wasn't sure where to start and where to end it, but we can start with G probably for now. I think it's C, D, E, F, G.
Okay, I got a little piano keyboard on my phone here. Well, so what do you think the first note was?
G. The first note of what I sent you, I'm pretty sure is G. It's G, F, D, E. Let me get my phone so I can hear it again.
I wish I could do two things on my phone at once here. Let's see.
Yeah, G, F, D, E, F. F, G, F, D, E, F.
Wait, G, F, D, G, F, D, E, F.
Yep.
G, F, D.
G, F, D, E, F. F, G, F, D, E, F. F, G,
Wait, hold on. It sounds more like G, F, E, D, F.
Oh yeah, I'm saying it backwards. Yeah, G, F, E, D, F.
G, F, E, D, F.
Yeah, because it went down the whole way.
Okay, so it goes G, F, E, D, F. Then what?
F again. G, F, D, E, F. Because it does like a quick
Okay. One, two, three, four. Do 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 do. Do 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 do. It's almost like you're doing triplets. Da 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 da. That's tricky. I'm not sure exactly what you have in mind there. It's like,
I just played it and it sounded kind of cool, and I was looping it, and then I was like, oh, I should send this to Zach.
Well, let's do a little music composition here. So we'll do a music composition TI style.
Ready?
All right. So we need we're going to use quarter notes as our basis. So Q equals Q. There we go. Equals, and we just need to give it a time, so let's just call it 200 for now. Then we define everything else in terms of quarter notes. So half notes are going to be 2 times quarter notes. H, not HS. Hello. What did I do here? 2 times. Okay, see what it equals 2 times Q. There we go. That's better. Eighth notes are going to equal quarter notes divided by 2. 40. Whole notes are going to equal quarter notes times 4. And we can add dotted notes if we need. Well, let's start there. Okay, so let's do call sound. Gotta remember the syntax here. I think it's duration, frequency, volume, I think, but let's go double check my memory. And then eventually we can shorten this. Rather than using multiple call sound statements, we can pack everything into a data statement. And then a loop that'll just loop through the call sound, play call sound, and then grab the data from the data statements. That'll be the most efficient way to do it, I believe. But let's do it old sort of the long way first, and then we can whittle it down. Okay, duration, frequency, and then volume. Yes. So duration, Q. Frequency. So you said F is the first, right? So F is first, right? G is first?
Yeah, G is the first.
Oh yeah. Dun 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 dun. Just trying to da 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 da. Okay, they're like eighth notes. Da 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 da. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4. Okay, so let's use eighth notes here. You can tell my grandmother was a music teacher, you know? You can't help but pick up some of it.
So cool. Yeah,
I used to play piano, you know?
Yeah, I don't know any of this part of music very well.
Yeah, I mean, I grew up playing classical piano. I was never great at reading music, but I was really good at playing. I was good at memorizing and playing, and had a good innate sense of what sounded good musically, you know. But so I remember some of the music theory. I was just never good at sight reading. Right.
Yeah, I never did music theory or sight reading really.
So
like reading really or writing.
We need our list of frequencies here. Although, you know, we might adjust them to use an older tuning of some sort. But let's just go with the standard notes for now, just to make it sound a little less, you know, a little more mysterious.
Mm-hmm.
Where are the notes? There they are. So these are sort of modern equal temperament notes. My mouse is really struggling. Sorry for those extra beeps, everyone. I just need to replace it. Okay, so starting on G, above middle C, so 392. 392, and we'll just use volume of 1 for now. So we should just, right now we should get, oh yeah, that's really short. So Q equals 500. Oh, 10. Q equals 500.
Oh yeah, that was good.
Maybe just a hair short.
Yep.
That's better. Do, 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 do. Yeah, that'll be better. Close enough. Okay. List. 60. Call sound. Do, do. Okay, so it's just another eighth note. Oh, do do. Yep. Call sound.
Yeah, eighth notes.
E. What's that?
The first 4 eighth notes.
Yep. Oop. Keep doing that. F 349. Oh. Change the volume accidentally. Doesn't sound right to me. What did I do wrong here? 340. I guess that's right. 392, 349. It's funny that it's tuned differently than the keyboard on my phone. That's interesting. Okay. Okay. 70, call it sound. Now we need an E natural right here. 330.
Oh, that's starting to sound better now.
Yeah.
Yeah, more notes, more context.
To D.
Yes.
294. Do 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 do.
F, and I think it might be a whole note, but it might be a half.
I think it's a half note. Half note.
Yeah, it might just be a half.
Back to F, which is 349. Yep, 349. Oh,
Yeah, I think
E.
it's a half. Then there's an eighth rest, and then there's another eighth of an F, and then it goes and repeats.
Well, yeah, we'll mess with that here in a minute. Let's get this phrase right. Oop, not an eighth note, half note.
Yeah.
Sounds pretty good.
Yeah, no rest. Just do another F now. Do another F, but an eighth note this time.
Why an eighth note?
Just because it just goes like, boop, boo, doo, 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 doo. It has like, it just quickly presses it one time and then back and repeats the last phrase again. Doo, 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 doo. Yeah, I don't know the timing all the way.
So hold on. Do do do.
The F one more time. Dun, 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 dun. The F repeats one time there. We don't have to, but it sounded smoother on the piano when I doubled that F. I held it for a whole half note, and then
Right, but what?
it went back to the G.
But then what? Okay, so I'm just having a hard time understanding what you want next. So do 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 do. Then what?
F. An F, but just quickly. Do, which I guess is an eighth note. Do, 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 do.
So do you want it to set? Do you want it to be kind of like this?
I don't hear anything.
Oh well. You don't hear that? It's not coming through this microphone.
Yeah, it's so weird. Music struggles to go through microphones for some reason. Like really good at just picking up the voice. Yeah, I can't hear
Let me
that.
play your original recording here and see if I can get a better handle on it.
So you should hear me double tap that F.
Okay, I don't know why I'm having trouble with this.
It's G, F, E, D, F, F, G, D, E, D, F, F, G, D, or G, F. Yeah, whatever. But yeah.
Do, 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 do. But the timing is different. That's what's weird. So the first one is. There's like an extra note in there. Do 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 do. Do 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 do. Yeah, but you're trying to keep the timing the same, but add an extra note in, which doesn't work. Do 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 do. Okay, that one we got. Do 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 do. 1, 2, 3, 1 and 2 and 3, 4. Oh, maybe. Okay, hold on. Da 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 da.
First one than it is the starting note for the next one. It's more of a closing note. Like the end of the first phrase, but it just like blends the two together. But yeah, I don't really know timing or how to write it well enough. but I can hear it. Like, it sounds better with the F in there than it did. And I was playing it on loop. That's how I played it, and that's what I found and I liked. But I just didn't know where to start it and end it. So I just picked like an arbitrary starting point in the loop. So that's why I think the timing got messed up. 'Cause, yeah,
Yeah,
these
it's
little supposed to be a little tag in note that's kind of in between, like taking a breath in, you know. Doo, doo,
yeah.
doo. Like resets the phrase theory well enough to express it in writing or anything, or to know the
Well, I
terminology.
guess yeah. Okay, so I mean, right now things are the first phrase is pretty easy to understand. It's 4/8 notes and a half note, which adds up to a whole measure. So then the next note is on the first beat of the next measure. So now we got to kind of do the math and divvy it up. Maybe that half note is just a little shorter on the second phrase. Let me try it and see. I think we just need a red herring. We need to hear it and go, this is what's right, this is what's wrong about it. So we'll start here at line 200, just to give us wiggle room. Call sound. So E. So this time we're starting with 349. Call sound. Starting with F, 349. Then G, right?
Yeah. Yep.
392.
Yep.
Then back to F.
Yep. Yeah, it repeats now.
Well, yeah, sort of. Okay, then we go down to 349, right? F, G, F. Maybe the timing doesn't matter. Maybe just, timing's weird and it sounds ethereal. Who knows? Let's just try it. I'm overthinking it. But it can't be the exact same phrase because we have an extra note in there. So, well, something's got to give. Otherwise, that's either the timing's off or something's got to give. One or the other. I don't have any deep opinion on it yet. I haven't heard it.
Well, like I was saying before, we could add the C in the beginning and start on C instead of starting on G, because I ended on a double C, but we could start on a C. I just didn't know where to start or end it. So that would add an extra note there, and I think it'll end up working out. The timing might be better that way. That might be what I did wrong. I just couldn't play it. If I started on C, it didn't sound right. So it felt like the very first time it loops, it should start on G, but after that, there's like an extra C at the end for no reason.
Okay, so here, let's see what we have. So we have the do 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 do. Then we have do 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 do.
Yep.
I mean, maybe it's fine. Maybe the timing doesn't matter. Oh, it's interesting. It's running these together.
I was about to say, did it even take? It didn't take a break.
No, and the system's not really good about doing it. Sometimes it has a tiny little break. I think it just depends on the timing cycles. The way to do that is introduce a rest here.
Yep.
But yeah, I think the thing to do is probably do this 90 call sound. H minus, I know this is going to be a little weird, E divided, let's give it a little 16th note rest.
Yeah, that would be perfect. It just needs a small one.
349, comma 1. And then what we need to do, we need to introduce call sound, E divided by 2, like 30,000. And real quiet.
Nice.
That's pretty good.
Yeah,
that just sounds pretty good.
Yeah, that made me smile.
So let's do the same thing with 250. H minus E divided by 2. We'll clean all this up and see if we can condense it down. I like where you're going with this. I do.
Yeah, this is sounding good. Yeah, this is funny. This is literally the first thing I did. I just started playing piano. This immediately came out. I was like, that's actually kind of good. I should record this and see what Zach thinks. And then I did, and then I just walked away from the piano after I sent you that text. I was like, thinking I was going to do more.
I like it.
Yeah, and then do 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 do.
All right.
Yeah.
So what's the last phrase?
All of that again except for the line 250.
It ends in a different note, right? It ends in C.
Yeah, it ends in C.
So let me get my.
And it plays one more C after that, so that's why I think that C might go in the beginning. And
So do 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 do.
Yeah, that will fix. No, because
That's okay. I think it's fine. It doesn't need to be super rhythmical. I'm sort of leaning toward not worrying about the timing and just getting the notes in there, and let me mess around with it here. Okay. So let's bump up to 300 here. Call sound. So we're starting on F again, right?
Yep.
Which is hold on. I scrolled past my stuff here. F 349. So E 349 1 310. Call sound. E. Now we want to go up to G 392. Back to F 349. So we want to go down to E, right?
Yep.
Then D and C.
Yep.
And C, we want to do the same timing trick.
Yep.
Okay. E. Let's see, what is D here? 294. 350, call sound. Okay, here's our C. So we want H minus E divided by 2.
Yep.
C is 262. 1. Then 360, call sound. E divided by 2. 30,000. It's the only way to create a rest.
Yeah.
Real soft, just in case.
Yeah. And
okay.
Then one more E.
What do you mean one more E?
One more C. An eighth note C gets played to complete the loop. It won't make sense if it just plays once, but if it loops, it should sound better.
Let's.
The same way that the F probably. Boom.
Let's get a loop going here. When does our music start? Hello, line 50. So 400 go to 50. Let's listen to a loop as it is and see.
Yeah, with the extra C in there, it'll feel less glitchy.
Okay, so you're saying at 370, call sound, E, and then C, 262. So it sounds to me like you're just starting on a rest. So the first note is not actually on the first beat. It's pause, so everything's offset by, which is kind of cool because it's you're not showing that you're offset until you get to the last phrase. Then you realize that it's been out of sync the whole time, and it adds up at the end.
Yeah, and then it loops well.
Yeah, that's it. You started on a rest. That's what's going on there. Okay.
Yeah, okay. Yeah, that makes more sense. Yeah, because when it started with C, it just right. Yeah, there it is. Very good.
You like it?
It loops well, anyways. I enjoy it.
It's not too bad. I like it. So now I think let's try condensing it down.
Okay.
So what I'm going to do is bust out a piece of paper here. I'm going to start. Yeah, piece of paper. That's what I need. I'm going to make some notes on these frequencies, and we'll see how condensed we can make this. So I think rather than so unfortunately these letters, these are all going to have to turn into numbers. So the timing was pretty good. What did you think about the timing in terms of the length of a quarter note?
I liked it.
Okay, so eighth equals, what do we? Oh no, quarter. Excuse me, quarter equals 600. I think the timing was pretty good. H would then be 1200.
We can play two notes at once, right?
We can, yes.
We could harmonize it with like an octave up or 2 octaves up.
Well, yeah, I mean, that wouldn't, it's, yes. Definitely could do that.
I think that could sound good if there's space for it.
So, but you just want an octave. You don't actually want any chords. You just want octaves.
Yeah, if it was like a C and then another C from from another octave up or 2 octaves up, so there was 2 C's playing at different octaves, and then like 2 G's playing, 2 F's,
Okay.
2 E's.
Let's let me see how far I can condense what we have first and see. So an eighth would be 300, and a 16th would be 150. And a whole note, which we're not using, would be 2400. Okay, now let's list 50 through 200. Okay, so our first phrase, do 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 do, all the way through. So 50 through 90 is our first phrase, right?
Mm-hmm.
All right, so I need to keep track of everything we need to list here, and because we have the rest, we have to keep track of the volume as well. Although we might, if at 30,000 hertz, if you put it volume 1, you might still get your rest. We might not need to have this at 20. So let's try it. Let's see. I think we'll just have to alternate. We'll do data starting on 8th note, which is 300. So 300, comma 392. I think we'll assume that if we play 30,000 hertz at volume of 1, people still aren't going to hear anything because that's well beyond the range of human hearing.
Yeah, I think hear over 20,000.
I think it'll be fine. So 300, 392. 300, 349, 300, 330, 300, 294, and then we have our half note minus a minus a 16th. So half note is 1200 minus a 16th, so 10,050. 1200 minus 150 is 10,050. Comma, boy, we are programming old school here. 349. Okay, then we have our rest. So let's get our rest in there. Then we have back to a 16th, which is 150, and 30,000. Okay. I know that people watching along can't see what I'm doing, but that's okay. Data. Now let's list lines. So that's all the way through lines 100. So let's list 200 to 300. And 300 is the start of the last phrase. So we want 300. And we're at 349. Then 300, right here. 392. Then 300. 349. Then 300. 330. 300. 294. Now we have our half note minus a 16th, so 1050. And the frequency is 349, right? And then we have our rest, which is 150 at 30,000 hertz. Okay, and that gets us all the way up through the second phrase. Now let's list 300 and beyond. Data. I'll type all this in here, and then I'll save this just to make sure we've got it, and then actually I might try to type it into our main program after all. Data. Let's see, we're at line 300, so we're back to eighth notes, 300. Unfortunately, you can't put variables in data statements. That would be much easier, but it doesn't work that way. 300, 349, 300, 392, 300, 349, 300, 330, 300, 294, okay, now we're at 1050 at 262, right? You following along? Did I lose you, Dale? Oh, you're there. I'm right here.
Yeah, I'm thinking, trying to understand what you're doing.
I'm listing the duration and the frequency. Duration, frequency. An eighth note is 300. And then 300, 349, 300, 392, 300, 349, 300, 330.
That's what it is. Yeah, I can't see your...
Yeah.
What is he doing? It's just processing in my brain.
You know, it's funny. I saw a video. It's just a kind of a guru. You know, guys that are investors and business people, and I saw a video from some guy who's like, use a notebook. The smartest people I know write on notebooks still.
We'll always stand by that.
Absolutely. The real problem solvers bust out a piece of paper when they need to solve a problem. I've seen it time and time and time again. Totally agree with that.
It's the note ones. They have the stylus on them.
Mm-hmm.
Anytime I get the slightest idea, I can just pull out my stylus and start taking notes.
Mm-hmm.
Yeah. I love. Yeah. It's a very good resource, writing things down.
Then we have our final eighth note, which is 300, and one more C, 262. Okay, I've got all my data statements. So now, let's save this. Dylan Music 1. Okay, now let's start over here. Okay, so 10 data. Here it comes. 300, 392, 300, 349, 300, 330, 300, 294, 1050, 349, 150, 30,000. One, okay, missing a zero. Yeah, there we go. Okay, that's the first phrase. 20.
Cool.
Data. 300. 349. 300. 392. 300. 349. 300. 330. 300. 294. 1050. 349. 150. 30,000. Okay, 300. 349. 300. 392. 300. 349. 300. 330. 300. 294. 1050. 262. 150. 30,000. 300. 262. Okay, there's all of our data statements. Now, let's come up here to line 100. Let's do I don't know if we need a, yeah, we're going to need a loop. So let's read duration and frequency. 110, call sound, duration, frequency 1. 120, go to 100, run. Data error in 100.
It needs a loop.
Yeah, you can't loop the data statements. I think what we need to do is figure out how many pairs we have here, and then have a loop. Yeah, we need a loop that, but not in the data statements. We need a loop down here. So let's do 100. How many pairs do we have? We just count the durations here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We have 21 for M for music equals whatever, we'll find a variable. 1 to 21. 110. Read duration and frequency. 120. Call sound. Duration, frequency, volume 1. It sounded pretty good. That rest sounded fine.
Yeah.
Next, M. And actually what we need to do Before we do that, we need to do a restore, because when the loop is done, we want to restore back to line 10. And then 140 go to 90. There we go.
Easy. So cool.
It's still quite a few lines of code, though. Quite a few tokens. I'm a little worried about it.
It is.
Tell you what, let me. I'm going to hit the restroom, and then we'll come back and we'll see if we can squeeze this into our program.
Me too.
Back in a second, everyone. Okay, I'm back. You back?
Yep. I just got back.
So, in terms of our title screen in our game, let's save this. Dylan Music 2. Do you want the music to start playing the moment the title screen comes on and then prints all the text, or do you want it to print all the text and then start playing the music?
Print the text and then play music, probably. Unless it can play the music while the text is printing.
Well, I think there's probably a clever way to do that. Maybe we need to start a new file here. So I can have a little playground in a playground.
Yeah,
So
it'd be cool if it was playing while it was downloading the map. When you have to have that little delay.
Yeah, unfortunately, it doesn't work that way. Because
then maybe right after. No, we'd want it before the delay or something. Maybe before the delay.
Yeah, unfortunately, if you start inserting stuff between the notes, it's going to play the note, do the time-consuming thing, and then play the next note.
So maybe play the. Yeah, it wouldn't be able to loop then, huh?
No, so
You'd have to do all the writing and then loop it.
I think that's probably, unfortunately, correct.
Yeah, and we have that delay built in.
Yeah, I mean, the other thing, I mean, we could certainly take the delay. We could certainly bump up towards the beginning and just have front load that to the beginning of the program before it does anything. We use the delay to that what do you call it, the array creation, whatever that's called, dimensioning. we use that dimension dim statement to create our delay. But that doesn't have to be there. It could be at the very, very beginning of the program.
Mm-hmm.
Right? And then...
Yeah, that might be better.
Well, okay, we could go... Let me... Where we saved this. Let's get back to our program here. Let's use a little imagination. One idea could be that we play a phrase of the music, draw a line. Play a phrase of the music, draw a line. Play a phrase of the music, draw a line. Then start looping the music.
Yeah, that could work.
But the timing will be a little weird. Because it takes time to draw stuff onto the screen. You know, not much, but a little time. But we could draw during the rest, though, maybe. See what I mean?
Yeah, just have to start messing with it and see how it sounds. If
Well,
it's too big a gap.
Well, let's paste our game in and then look at the title screen for a second and see what we can kind of imagine in our minds before we start building stuff. That's why I don't want to mess with things too much because we're going to tear apart our title screen to insert the music here.
Mm-hmm.
So we could print Socrates and then go do 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 by do 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 Zachary Fruling and Dylan Metzing, do do do, so on and so forth.
Yeah, I'm interested to see what that sounds like.
Yeah, me too. But let's kind of get the title screen on the screen here and remember. Let's kind of envision what it might feel like before we start tearing it apart.
Yeah.
Because we already have a bunch of data statements inside our title screen already too. So okay. So right now it just all loads at once.
Turn off the throttling and.
Oh yeah, definitely.
You can see it load slow.
So let's say we print Socrates. Socrates do 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 by do 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 Zachary Fruling and Dylan Metzing do 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 do. Don't worry about the different. And then loop copyright Spark Gap Games do 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 press any key do do do, and then we just kind of go and do a loop from there after press any key shows up.
Okay. Yeah, we can try it out and see how it sounds.
I have no idea how to do that, so let's. I think what we need to do. Let's take our code here. We have a lot going on in this already, and we don't. And how much space do we have to work with? A whopping 388 bytes. I think I'm really worried about being able to fit it in there.
Yeah.
Well, let's paste this into a new file. Just this.
Maybe just try in at the end at first and just see if it fits or not in its entirety. See if it's too big.
Oh, sure. I see what you mean. To do that, I would have to... Okay, this is going to be super tedious and annoying, but let's just do it. Typos. list 1 or 10 to 100. All right, I guess I can do it on my paper here. We're in our new file here, so let's just do 10 data. We're not worrying about the line numbers right now. 300, 392, 300, 349, 300, 330, 300, 294, 1050, 349, 150, 30,000. We could probably keep going, but let's just data 300. It's amazing how short the line looks compared to how it looks on the TI. Huh?
For real.
349, 300, 392, 300, 349, 300, 330, 300, 294, 1050, 349, 150, 30,000. 30 data. 300, 349, 300, 392, 300, 349, 300, 330, 100, 294, 1050, 262, 150, 30,000, and here's our trailing C here, 300, 262.
Nice.
Okay, then list 100 and above here. Oh, 90 and above. So 90, restore 10. 100. For m equals 1 to 21. Let's just see if we're in the right ballpark. I won't worry about condensing this yet. 110, read df. 120, call sound. df1. 30, next m. 140, go to 90. Okay, so this is not the version. Let's just change these line numbers. Let's make this, I don't know, 20,000. Apparently the line numbers don't really matter from what I gathered. I was doing a little reading on this. They all store them as a certain memory location. Doesn't matter how many digits there are in the line numbers.
That's good to know for next time too.
Mm-hmm. Go to 20,030. Okay, so what I want to do, let's paste our existing program in. Then we'll paste our music in and see if we're even in the right ballpark or not. Sound like a plan?
Yes, sir. Make sure it works.
Well, yeah. Well, we might be 300 bytes over, and no dice, right? So.
Exactly.
And this is not the final version, but at least let us know whether this is worth pursuing or not. I think, because this stuff will all have to be there. The data statements. It's this stuff that's we're gonna have to interweave in the existing code that we have. I'm not at all clear how we're going to approach it, so we'll just see what we can do. Part of the fun of discovery, you know? Never know what magic we're going to come up with until we dive in.
Exactly. That's how you find those happy accidents.
Okay, so now, let's just see, we have 2,628 bytes. Let's paste in our music. And see how much memory we have left. Okay, I think that's going to cause an error. I think that's too low. I think if we try to run it, well, it's running okay.
Didn't hear any music.
There you go. 31 bytes left. No, you wouldn't hear any music because I just bumped the music down to the bottom with a bunch of low line numbers that are never being called.
Oh, okay.
So now, if we want to get the music, so the task is to merge these two things together in a way that makes sense.
Yeah.
Yeah, that's right. So let's come down here. Excuse me. Go sub 14,000. What is happening there? As you're drawing the corners of our title screen. Okay, 6,400. Go sub 14,000. All this is going to be the same. We're going to draw the background first, right?
Yeah. Yeah, draw the background and write Socrates before any music plays.
Excuse me. So right now, Socrates is being... It's inside that loop. Let me think. I'm gonna... Nothing to lose. We're in a sandbox here. Let me just try... Because if the idea is to draw something and then play the phrase, draw the next line of text, then play the phrase, we could build that into the data statements.
Okay.
So, 6420 data 4, 10, Socrates. Okay. Then we play the first phrase of music.
Yeah.
So, 300, 392, 300, 349, 300, 330, 300. I like this because it's combining data statements.
Yeah.
It'll actually save us a few bytes if I can figure out a way to do this in a way that makes sense. 1050, 349, 150, 30,000. Okay. 6430. Data. Okay, then we want to say buy on its own line, right?
Maybe we could try that first. I'm also thinking that if we split it up to where it was Socrates, then the first music, then the buy our names as the second chunk of music, then the copyright as the third right.
Oh, sure.
And then it,
I see where you're going with that. Yeah, let's try it.
yeah, it might look more seamless.
Okay, so let's do this. 6430. Restore 6420. Then let's display at. Now this is where I gotta. Oh, we need to read. Let me think. Hold on here. Read. We're using B, C, and D string. Okay, that's fine. Read B, comma C, comma D string. Display at B, comma C. This is displaying Socrates now. D string. Okay, and then how many pieces of music are there in this first line? 1, 2, 3, 4. Wait, hold on. 1, 2, 3, 4, 5, 6. 4 MU for music equals 1 to 6. Read duration and frequency. Call sound, duration, frequency, comma 1, next, MU. All right, so this will take everything in this first data statement, start out by reading the text, display the text, and then it'll create a loop. It'll keep reading the rest of this data statement, and at every time it goes through the loop, it'll play the next note in that line. And then 6440 data. So it might be a little convoluted, but I think it's okay. So you want we need all the information for by Zachary Fruhling and Dylan Metzing, right? Okay, so
Sorry.
we have what?
Sorry.
Oh, it's okay. I'm just talking it through. So up till now we've got everything Socrates and then the first phrase of music. So then we want by Zachary Fruhling and Dylan Metzing all together, right?
Yeah.
So data 8, comma 14, comma by 10, comma 7, comma Zachary Fruhling, comma 12, comma 14, comma 8, comma 12, 14, and the ampersand.
Yeah.
14, comma 8, comma Dylan Metzing. Let's just do 6450 data. Now our second phrase of music. So 300, 349, comma 300. I guess I can paste this in. I can just paste it. What am I doing? Hello. I don't think all this is going to fit on the same line. Maybe let's try it. Might have too many. We might get a line length there if we try it. Might be okay actually. I don't know. It's a lot. That's a lot of information in one line though. I think maybe we'll get a. What's that?
I think it fits line length wise.
Yeah, I'm worried about the number of tokens though.
Oh yeah.
Because we remember there was a token max. We would get a line length there because of the number of tokens in the data statement.
Yeah.
So I think we'll do this. 6460. Now restore 6440. So read that data statement. Now we have 1, 2, 3, 4 lines of text we want to print, right?
Yeah.
So for, I guess we can use mu again, it's fine. Mu equals 1, 2, 4. Read B, comma C, comma D string. Display at B, comma C, D string. So that'll print the 4 lines of text. Next mu. Then we have, okay, let's just 6470 for mu equals 1 to, how many lines are in this, phrases are in this piece? 1, 2, 3, 4, 5, 6, 7. 1, 2, 7. Read duration and frequency. So far, this is working pretty well. This might be okay. I'm not sure how it's going to sound. It might be a little choppy because we're trying to do too much stuff between the phrases, you know.
Mm-hmm.
But we don't know until we try, right?
Exactly.
Call sound, duration, frequency, and 1. Next mu. 6480. Okay, so here, let's do data. (19, 6, 2026). That's the date. Spark Gap Games. Now press any key we're going to do differently, right?
Mm-hmm.
So let's do, let's get our music lines in here. Hopefully that'll be okay. 6490. Restore to 6480. And we only have one phrase here, so we're going to do read B, comma C, comma D string. And we're going to display that right away. Display at actually, since it's the only thing being displayed there, why are we even... No, it's okay. Okay. It's fine. Display at B, comma C, D string. Okay. Now we need to get that that special character in there, right here.
Yeah.
It's this one, right? 19636. Call VCHAR. Yeah, 19, 6, 36. Let's double check. Let's just double check. That should be the $sign in our character list here.
Yeah.
Oop. 36. Yep. Yeah, okay.
Nice.
Okay. So that prints all the text. 6,500. And we'll have to condense the line numbers a little bit probably. 6,500. How many phrases are there? 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8. For mu equals 1, 2, 8. Read duration and frequency. Call sound, duration, frequency 1. Next, mu. Typos. 6510. Let me look at the original code here. Is there a 6500? I think there is. I think I'm going to have to compress this a little bit. Yeah, so it's all got to fit inside here, so we'll have to change these line numbers to be able to paste it in. Okay. Let's just leave it the way it is with the this for now. There'll be this weird pause where we take this whatever it's called, the dimension statement.
Mm-hmm.
Wait, no, we dimensioned up above, right? So this is actually, so we did the dimension statement. Now we're actually assigning values to the variables. The dimension statement's already up there, right? Am I looking right at it and just not seeing it? Oh no, it's here. Okay. Oh yeah, yeah, it's at the top. Okay. So that's the dimension statement. So it is doing that at the beginning. I think we could actually move in the interest. Have we all been playing Midnight at all? Yeah, definitely. We played some this morning, actually. Right now we're working on programming our retro Socrates game in TI Extended Basic for an old computer system, the TI-99 4A. But yeah, we've been playing World of Warcraft Midnight for sure. We're, I'm always like half an expansion behind, so I'm behind a lot of people, but definitely spending time doing it. So I think what we can probably do is front load this, the assigning the value. We're using it as a pause, right? So we can come up here and assign the variables to that array, the values to that array, before it ever starts drawing the title screen. So right here, go sub 6400, we just add another line. I hope this works at all. I'm just worried about the memory usage, mainly because this is pretty bulky.
Mm-hmm.
But let's just do everything else here for now. So all of this. Oh, we need another data statement. So we need the data for press any key. Although maybe we can just put we can just do this because there's only one value here. So let's just do display at oh wait, did I get Spark Gap? Oh, I did. Spark Gap Games. Yeah, that's in there. So display at 22,7. Press any key. So now we want it to loop through those 3 lines of music until we press any key, right?
Correct.
All right, so let me think how to do that. Oh, this is getting bulky. I'm really worried about our memory usage. Let me think. So basically we want music loop, ML for music loop equals 1, 2, 3, because we have 3 phrases of music to go through. Um, 6530. This is getting so convoluted. I knew it would be. We're trying to be too clever, and we're not going to have memory for this. I'm just sure of it. If ML equals 1, then restore to 6420. $65.30. If ML equals 2, then restore we might have to do the same little trick of a trailing 0 on these data statements.
Oh, yeah, that could work.
Because they're different lengths.
Yeah.
Oh, man, this is not going to fit. Look at this. Look how long this is getting. It's not going to fit.
I only have 30 minutes left. Need a way to condense it somehow.
Out of curiosity.
Could you make 300 be like a letter or something?
No, you can't. You can't have variables inside data statements.
Oh, yeah.
Let's just see how bad a shape we're in here. Oh, look, there's no room for this. Look. It's not.
I'm taken out already, too.
What's that?
That's with the old one taken out. Not like repeating.
Yeah, that it overwrote everything in that 6400 block.
Yeah, this way is much bigger.
Yeah, it's just not. It's just a non-starter.
Yeah, that's not gonna do it.
Damn, it's like we're on to something. We just need more memory.
Mm-hmm.
Sorry, I'm just running through a few permutations in my mind of how we might condense this further, but I'm not coming up with very much.
Mm-hmm.
We could. I don't think it matters, but I think it's not going to get us enough memory back. But we could take. I see where you're going with putting. It wouldn't be variables, but we could put like E here for eighth note. Yeah, we'd have to come up with some letter, and then we could have some code below that says if whatever. When we read this, we'd read it as a. Actually, you know what we could. We could do. Because these all just have a bunch of extra zeros. Watch this. Hold on. I'm onto something here. Problem is these don't. Yeah, I mean, we can't use decimals because if we go into using decimals, then we have to we can't compile. The compiler doesn't handle decimals; it only does integer math. Apparently, I was hoping we could just drop a couple, then down here in the duration we just do du times 100. See what I mean? Instead of 300, we have 3, and then down here we just do du times 100. 300. But that doesn't work. We could do 30. And this would be 105. This would be 15. And then all of a sudden it's du times 10. Clever, huh?
Yeah.
So
we can do that for all of them.
Yeah, again, we just can't use decimals. We have to stick to integers. Du times 10. Ooh. And same thing here. That's not going to get us enough memory back, though. It's a nice idea, but it'll help, but it's not going to help enough.
Yeah, it helps a little. It's like 21, something like that.
Well, let's see here. Let's write it out, and then we'll see if we can condense it. We'll just do it. So if that's the first phrase, 6420, the second phrase is here at 6450. $65.40. If ML equals 3, then restore 6480. Problem is now we have a different number of items in the data statement preceding our music. But we could do this.
Hi, my love.
Hey, my love, what's up?
I wanted to check in and say hi, and I love you.
Love you too.
I was just talking to my sister for about an hour.
Oh, okay.
So it was nice. We just had a nice little conversation.
Everything copacetic?
Oh, everything's great. Yeah.
Good.
No, we had a great conversation, and we even FaceTimed, and
Good. Sounds
so
like
it was nice.
everyone's getting along again. Good.
Yes, I agree.
I love you.
I love you.
I'll see you in a bit.
Okay, my love. Have fun.
Thanks, my love.
Love you.
Love you too. This is just so convoluted. I don't like this. It's too convoluted.
Yeah, and it's getting longer.
It's not going to fit. It's just a non-starter.
Yeah, it's getting
All right.
so much bigger.
What other ideas do you have?
Nothing right now.
Let's go back to our main game here. Let's paste this back in. A little fresh paste here.
Can we make the GFED like a subroutine or something, since it plays 3 times in the same
Oh,
order?
sure. I mean, you can definitely play the same. Oh, wait. You mean? Well, it
Yeah, I don't
doesn't.
know exactly.
In the second 2 iterations of the, it's basically the same.
Yeah, it plays the GFED all 3 times.
But the problem is not so much that. The problem is in incorporating it with the rest of the stuff we need to do. It's chewing up information so fast.
Yeah. Yeah, there's so much to add that in there. Yeah, I was trying to come up with something even shorter, but that was just the first thing that I played out.
Well, okay. Rather than a title, let's just think about this differently. Rather than title screen looping music, what if we just have like a little opening fanfare? Do 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 do. Whatever, something. I don't. That was just silly, but
Okay, yeah, like just some sort of little jingle that plays that
a
doesn't loop.
super quick little jingle that doesn't loop.
Okay. Yeah, because looping, it's getting too much.
Something quick, something musical
Yeah.
but quick.
That's easier. Something musical, quick, Greek-esque. Something that makes you think of Socrates.
Yeah, I mean, just like a little, almost like a harp. Just a bunch of notes on a harp. Quick notes.
Okay, yeah. Have to play around with ideas.
Actually, let's try it.
Yeah.
Let's do some interesting chord, like I don't know. I got an idea. I'm just gonna spitball this, but let me try it. Calls 10 call sound. Actually, let's start with our quarter note again. Let's make them all quarter notes. Actually, just D for duration, because we're gonna make them all the same. We'll start with 100. Okay. I need to look at a piano keyboard. There we go. And I need my frequencies. So let's start with an A above middle C. So 440, call sound, duration 440, 1, 110, call sound, duration, let's do F sharp. It's a nice sounding chord. 740. No, wrong one. Right here, 370. I have no idea if this is going to sound good at all. D sharp. 311. C.
Oh.
Hi, Dinah. No, I don't like where this is going. I was hoping to sustain them, you know, not just play them in sequence, but sustain them, you know, as they go.
Yeah, yeah.
I don't think there's a way to do that. Oh, maybe. Hold on. Actually, maybe. Hold on.
Yeah, if you built it into like a chord type deal.
Yeah, exactly. Q equals, what was it, 100? Whatever. Call sound. So we just play one note at first.
Yeah.
Which was A, 440. Duration, 440, comma 1. Duration, 440, comma 1, comma. Now we get this the next note, which is F sharp, 370. 20, call sound, D, comma 440, comma 1, comma 370, comma 311, I think it was, right? Yeah, 311. And actually, we could decrease the volume of the first notes so it sounds louder as it goes down the chord. We can adjust that in a minute. D. Right here, we're a little stuck, but that's okay. The first one's faded out, so we'll do 370, comma 311, comma 262. Oh, wait a minute. Comma 1, comma 311, comma 262, comma 1. Oh, 10. D equals 100. 120. Ah, yeah. Wait, why are we getting a bad value there? What am I not seeing? D 440, comma 1, 370. Oh. Insert, comma 1, comma. You do the same thing there. You did. That sounds kind of cool. 130. Call sound. Oop. No. That's not terrible.
Interesting.
Yeah, I don't know what to make of it, you know.
Yeah.
on, I got an idea here. Diana, you're okay. Hold on, Diana girl. I don't know what to make of it. It's a cool sound, though. I don't know what to make of it. I don't know if I like it at all for anything. It just sounds cool.
I can't tell if it's for Socrates, but it does sound video gamey.
Another option is to ditch music altogether and just to have it go when the text pops up. Just play one of our little sound effects.
Oh, that's true. Yeah, just like his walking sound effect.
Yeah.
Yeah. Yeah, that would sound good.
It would be something, you know.
Yeah.
Let's look at the...
Just something like the sound effect that you did could sound good after everything's loaded. Press any screen, any button to continue.
It's not terrible.
Yeah.
So let's take a look here, though, because we have... right now, it's drawing all this at once. So how many things are we drawing at once? 6 things, right? It would be cool if it were 4 things. 1, 2, 3, 4.
Copyright. Yeah, 6 things. Yeah, if the copyright and its line are one thing.
Yeah, I don't know though. What's our sound we're using for the walk? Let's see, it's Go Sub 6300, I think. No. Yeah, maybe Go Sub 6300. No. Where's the sound being played? $6,600, $6,700. Let's see. $6,700 is the sound. Let's try something here. Just see what it might look like in the simplest possible way we can squeeze it in there. I mean, that sound effect shows up a lot. I mean, it's kind of almost a theme of the game. Is just walking around Athens, right?
It is.
So it could be.
Yeah. Yeah, I like that idea.
It's an idea.
Yeah. A pretty good one. And then having like a little or some sort of little sound effect at the end of that could sound pretty good.
It uses what we already have, and that.
Yeah, it could be even something simple like that, just 2 notes. Yeah. I think it'll have a nice rhythm. Sound good.
What might be fun, like even like the chord at the beginning of Mystery Science Theater 3000, at the end of the theme song. Do you have any idea what I'm talking about? Are you a Mystery Science Theater 3000 fan?
I'm not sure what that is.
Wow, I feel so old. You don't know what Mystery Science Theater 3000 is? Okay, I'll have to explain it here in a minute. Let's just see how this sounds. It wasn't terrible.
Yeah, that was pretty good. I want another one when the precedent happens.
Yeah, let's just see what it's like with... Oh, wait, that was normal? Oh, it was. Yeah.
That was normal speed? Oh,
yeah. Hold on, let's see what it's like. Okay, hold on, let me... I want to play something for you, but in fact, what I'm going to do, I'm going to mute my... Well, no, it'll be okay. Mystery Science 3000 chord. You don't know Mystery Science Theater? So it's basically a comedy show where there's a guy stuck in a spaceship with 2 robot companions, and they watch old movies and poke fun at the old movies as silhouettes on the screen, and there's like puppet comedy sketches in between the segments of the movie. And you've never heard of this?
No, I haven't.
Okay. Well, at the risk of getting a copyright strike on my channel, let's go to YouTube. And, if you're watching this and, either there's no copyright strike and we can watch it, and if I get a copyright notification, I might bleep this part out. Oop, not that. So if you're watching this and there's no sound coming up for the next 30 seconds or so, just skip ahead a little bit. Bear with us. So Mystery Science Theater 3000. Opening credits. So the nice thing about the show is the opening credits tell you everything you need to know about the show. So let's find the good ones. Let's find there's hold on here. Intro. Okay, so this shall tell you everything you need to know about the show. You should be able to hear it, hopefully. Did you hear that chord?
Oh, yeah.
Yeah.
It's beachy.
Beachy? Like, what do you mean beachy?
The tone of it just makes me think beachy vibes.
Like beach music? Like old 1960s beach rock and roll?
Yeah. Yeah, or like California in general. Yeah, like the Beach Boys or something, probably.
Well, let's go to, like Jan and Dean maybe. Okay, let's go down here and let's try getting that sound effect in at the press any key.
Yeah.
I'm just trying to think of ways of reusing what we already have without adding too many more tokens here. Okay, so press, yeah, so display at right here. So we just want to do it right here as well. Let's see, and we're doing display at, and then go sub 6700, right?
Yeah.
Okay, that should be fine. Let's paste this in. Love it.
Nice.
I mean, it's something.
Hmm?
I'm not in love with it, but it's, you know, it's better than nothing, right?
It is.
It's reminiscent of our typing sound effect, you know.
It is. Hmm.
Do you like it? Should we keep it?
I do like it. Yeah, at least for now. Better than no sound.
I mean, when we compile it, it's going to be more like this.
Yeah. Maybe at that point we might build in a delay or something.
For the last one?
Maybe. Or yeah, I mean it's fine like that. If we can come up with some sort of music, that would be cool. But yeah, I guess there's no music in the rest of the game either. So
Mm-mm. I do want to see if I can figure out what that chord that is. E7.
sounds probable.
Hmm. Dinah. That's an E7. Out of curiosity. Oops. Keep doing that. There we go. G sharp, 415. B. No, wait. Yeah, B. Um, 494. Oh wait, 330, comma 8, comma 415, comma 1, comma, what was it? 494. No, this would be 494, right? Yep, comma 1. And 415, we only have 3 notes at a time, so 415, comma 8, 494, comma 4, and we want a D in there, 587, comma 1, 130. What did I do wrong? Oh, need the duration.
Hmm.
30. It's weird. It's different. Again, I'm not in love with the idea. It's just, you know, it's worth fiddle farting around with for a few minutes and see if there's anything related to it that we can come up with.
Mm-hmm.
Oops. It's interesting.
Is
I'm not sure I like it.
yeah, same.
I mean, just kind of picture what it would sound like. What? Wait. There's 6 of them, right?
Yeah. 6.
I don't know. It sounds silly.
You need to like listen to some popular Greek tunes or something.
Well, modern Greek music is quite different than ancient Greek music. But
Yeah, I don't know what.
I mean, we could play the here. Let's find the. Let's go to YouTube here.
Yeah, need an example.
So, Aeschylus Epitaph, the first complete ancient Greek music. Here we go. Maybe after an ad, we'll see. Okay, I got an idea. Those chords that are repetitive, da, 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 da. What if we did those every time we put something on the screen? Da, 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 da.
That could be fun. Yeah, let's try it.
It's an idea. Let's see. Somewhere I had put in the design document, I think. What's
Go
that,
kind
sorry?
of fast. Said it. I guess it'll go kind of fast though once it's compiled. Like dun 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 dun. Be too
Yes, that's
fast for me.
true. That too fast. Yeah, and too fast, actually. Yeah, you're right.
Yeah, it might be like da 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 da.
Yeah, you're right. And so we'd have to add a bunch of delays in.
Yeah, to get it to play at a more appropriate speed.
Hmm.
Yeah, so it'd be like a its own thing. Like start playing after
Also,
everything is
there's just no way
programmed.
to get that stringy sound. That it's just gonna sound like beeps. Doo, doo, doo. It's just not. The TI doesn't lend itself to that kind of intonation.
Yeah.
Let's see here. I have a link to the Wikipedia article on this. So I think it has the melody. Yeah, that's why I saved that. Here's.
I like
That's
that second phrase.
you like which part?
The second part of the top phrase. It's mainly that last bit there. Dun, 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 dun.
Let's play it again. So it's which part? Tell me, like where?
Yeah, right there. I think is like those last four notes. I like the dun dun dun. Yeah, I just need to find something to go around it a little bit. Maybe it's the three that go down, and then those four followed by the next one and the next line. Hold on, let me get my computer closer to me so I can see the words. The at all grieve, oh thou grieve for the notes from that. At all thou grieve for those notes. I think these three go down. Here. Stops there.
I mean, I kind of like this whole first line, really.
I think that'll be too long.
Actually, you know what I think? I think if so, pay attention to the line. This last note right here. If it were the same as the starting note, it would feel like a complete phrase. Right as it is right now, it feels like it needs to continue. It's not resolved. But if it resolved in the same note as the very first starting note, this whole first line could be a pretty nice standalone phrase. So imagine it, but with the last note, imagine it totally resolved. Rather than da da, it'd be the same as da. It would be the same as this note, an A.
Yeah. Dun, dun, dun. Yeah, that would sound better.
I mean, we
And then it
can.
just ends loop.
Yes,
Just like
exactly.
one
Right.
stop. Sure.
And it could be the kind of thing where we ditch the idea of incorporating it into the text showing up on the screen, and we just play it when pressing a key shows up on the screen.
Yeah.
I could live with that. Why don't we take a stab at turning this into some music just to see what it sounds like?
Yeah.
Okay, so we're going to need, what do we need here? We're in 6/8 time. So we need eighth notes, quarter note, dotted quarter note, and that's all. And then maybe this will trail off a little bit. So let's see, new. So 10 quarter note, and I don't have any idea. Let's just do 200 for now. 20 eighth note equals quarter note divided by 2. 30 dotted quarter note DQ equals Q times 1.5. You do know about dotted notes, right?
I'm sure I was
Yeah.
told about
So
that
dotted notes
before.
increase the time by 50%. So this is if a quarter note is, this would be a quarter note and a half of a quarter note and an eighth note together, run together
Oh, okay.
in length. So
Cool.
eighth note, quarter note plus an eighth note
Dang.
in time. No, not in sequence, but in terms of duration. Okay, so all we need is eighth note, quarter note, dotted quarter note, and that's it, right?
Yeah.
All right.
Yeah. I see.
Now, what we're going to do, just in the interest of making this easy on ourselves, we're going to do, what notes do we need here? What key are we on? Fuck, I don't remember my key signatures. Saved my life. All right, so we have C sharp, that's a C, D, C sharp and E sharp. Key signature 2 sharps. I don't remember. D major. Oh wait, is it F sharp? C, D, oh yeah, C, D, E, F. C sharp and F sharp. So we're in D major. Okay, that works. Sorry, I'm so out of practice with music, I have to kind of remind myself at every turn.
Yeah, you're
So
good.
anytime we encounter a C or an F, we need to make sure we use the sharp. So this is a G. So let's start building a library for ourselves here. So 40 G equals, let's move this over here, 392. What's the next note we need here? E. This is E above high C. So right here, 659. I don't think we get down to, yeah, we don't get down here anywhere, so we don't have to worry about that. Okay. This is B. Wait, no. Hold on. Yeah, it's hard to see on this screen. Yeah, this is C. So this is C sharp. So C sharp. CS equals 277. Wait, no. Not 277. I want 554. Okay, then we have D. $587. Fun, huh?
Very
Okay.
cool way to pick.
E. We already have E natural, right? Yep. Okay. C, D, E. Back to D. Back to C sharp. D, E. D, C sharp. B. We have B? No. So B. Oh, wait. We just overrode our E here. Okay, hold on. 20. E equals Q divided by 2. 50 E natural equals 659. And then we need B. So, yeah, this is B right below high C. So 494. Is this all new to you, Dylan?
Yes. Well, I guess kind of, but
A.
not all the way, but for the most part, yeah. The coding aspect of it,
Mm-hmm.
yes, but some of this I do kind of have familiarity with, but not
Mm-hmm.
much. I did one music theory class in college, and then just whatever I learned through K through 12.
That is all the notes we're going to need for this little melody. So let's see. Call sound. Going to be quite a few call sound statements here, but that's okay. Let's just see how it goes. Okay, so we've got A to start and an eighth note. So E, then A, and volume of 1. Then we have a quarter note at E. E natural. Actually, no, quarter note, then E natural, and 1. Then we have a dotted quarter note, so DQ, and we are at still a D natural. It's important to be natural.
It is.
Okay, then we're at C sharp. At what? These are eighth notes, so eighth, comma C sharp, comma 1. So E. Wait, no, wait, that's C, right? Hold on, what did I do? Oh yeah, C sharp. Okay, yeah, I just lost my place. C sharp, D, eighth, comma D, comma 1. Call sound. Eighth, comma E natural. back D, dotted quarter note, so DQ, D, comma 1. C sharp for a quarter note. Curious what this is going to sound like, you know?
Same.
So D, eighth note. E, D, C sharp. These are eighth notes, right? Yeah. E, D, C sharp, B, eighth note, B, A, quarter note, eighth note, B, call sound, and it was a quarter note. And here we're going to change it to A, back to A to resolve it. All right, this will be interesting. Subprogram not found. That. Oh. Wait, why is there a subprogram? What? What am I missing here? Call sound. E comma E comma E comma E natural comma 1. Okay, I'm totally confused. Why is it throwing me an error here? Oh, I see. Zero.
Oh, zero.
Okay, so let's slow this down. 400. Too slow. 300. It's not too bad. Let's see. 1200 go to 1000. There you go. It's about as ancient Greek as it sounds, I guess.
Very cool.
I don't love it. I don't hate it. It's interesting. What do you think?
Yeah, I feel that. What's the process of making it 2 chords instead of 1?
2 chords. 2 notes?
Or 2, yeah, 2 notes.
Yeah, we just have to insert other notes into each of these call sound statements.
What are we at some?
I wonder.
Too big for that fit.
Well, I don't even know. It's what is it using 300 or 400 bytes right now? I mean, right now we'd have to find another way to do this because it's just too many lines to add in. I don't love it. It's too fast.
That's what I was thinking. It's a little fast, and I was thinking or if it was playing a lower one and that higher sounding.
I think I don't like the I don't like the eighth note at the beginning. I do want it to go do 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 do. I want it to be a quarter note, not an eighth note.
Yeah.
So 1,000. Let's try this. Almost, maybe even like, hold on. Let's try this. Even if it breaks the timing a little bit. Insert. That's better. What do you think?
Nice. I'm liking it.
But what it needs, 1150. Hold on. If one other place I want to lengthen it. Hold on, I got an idea here. This note right here. I know we're taking some liberties, but that's part of the fun. That would be the B. 1140. It's about a quarter note. No. Hold on, it's not sounding quite right yet. This needs to be a dotted quarter note. That's what I don't like. So that A. How about that?
Yeah, I like that.
There's one other place I want to slow it down. Do 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 do. Hold on. Instead of a dotted quarter here, let's make that a half note. Okay, so it's the second D. Right here, 1060. We don't have a half note yet, but let's just do Q times 2. That's better. Do you like it?
Ew. Yeah, I like these little changes that have been happening to it. I think it's just getting better and better sounding.
Yeah, well, I got a pretty good ear for timing, you know.
Yeah, I like this. Sounding good.
It's one other place. Tempted to try to lengthen this one a little bit. Let's try it one more time. Yep, right there. That one. That note right there, the C sharp. Right here. Let's try dotted quarter. Oops. There you go.
Yeah.
That's better.
There you go.
That sounds much better.
Yeah. I think every little tweak you were doing, I was like, yeah. There we go. Yeah, I'm liking how it's going.
I'm gonna turn the volume down a little bit for me. That's part of it. It just doesn't need to be too loud. It just needs to be soft in the background.
Yeah, definitely doesn't need to be a full volume.
Let's, okay, let's do the same kind of data statement routine. Because happily, I mean, it's a pretty good, sounds pretty good on its own. You know, it doesn't need much, it doesn't need harmony. And Greeks didn't really use a lot of harmony like we do now. So the timing feels pretty good as well. So list 10 to 100. So what are we really using here? We are using quarter notes. So Q equals, the timing felt pretty good to me. How about you?
Yeah.
275, eighth note equals, Q divided by 2. Oh, this is where we got to be careful. So we can't use, we can't use decimals. So let's try 280. Sounds pretty good.
Nice. Yeah, I like that.
Okay, so Q equals 280. Eighth equals 140. What are we using here? Dotted quarter. DQ equals, maybe it's in my head, but I don't feel like it, 280 times 1.5, 420. And we're not using halves at all, right? We're using sixteenths. Okay. So let's see, 280 divided by 4, that's 70. So 16th equals 70. That's everything, right? We're not using, oh, we are using a half note as well. Okay, half equals, what is that? 560? Okay, data statement time. So let's list. Oop. No, get in the right window. Okay, so dotted quarter, 420. Let's see, we need our frequency list here. Shit, I have 2 windows open. Hold on, I can do it in 2 steps here. 420A quarter, 280 E natural, dotted quarter, 420 E natural. Oh, wait a minute. Oh, yeah. Okay. 420 E natural. Eighth note, 140. C sharp. Eighth note, D. Eighth note, E natural. Quarter note times 2 is half note, so 560. D. Dotted quarter is 420. C sharp. Eighth note, 140. D. Eighth note, E natural. Eighth note, D. Eighth note, C sharp, 8th note, B, dotted quarter, 420, A, 8th note, B, dotted quarter, A, and our rest, 16th note, 70, and 30,000. Okay. let's save this because this sounds pretty good. Ikalos 1. Yeah, new 10 data. Oh, we forgot our notes. Ah, shit. That's okay. Let me take another stab at this. Okay, I'm going to, you can see my screen, right? Devlog, what you doing? Hello? I think I lost you.
Yeah.
Oh, you're here?
Sorry.
It's okay.
Sorry.
What's up?
Nothing. I'm just tired today. I keep getting close to snoozing off. I'm just laying here, taking it in. It's kind of warm in my room, just relaxing, processing new information. But no, I keep like getting right on the edge right there. But I just pop back up. I'm like, okay, I'm just not gonna lay down anymore.
That's okay.
My warning sign. That was too close.
Okay.
I don't think I can fall all the way asleep because you're still talking. It'll wake me up. But yeah, I don't want to be like lackadaisical like that. It's just too warm in my room. I think it just got too hot. Is that perfect? Like too warm where you start falling asleep? I don't know if that ever affects you or not. You're in a
Oh,
warm
sure, of
room.
course, yeah. Especially when I'm driving, you know.
Yeah, it's like too warm in here. I need to. I'm gonna go turn on my fan.
Okay, E natural, right here, 659. 420. Sorry, I'm working on paper here. E natural, 659.
That was funny.
140. C sharp, 554. I'm just working on compiling the information for these data statements.
Yeah.
140. D, 587. 140. E natural, 659. 560. D, 587. 420. C sharp is 554. 40. D, 587. 140. E natural, 659. 140. D is 587. 140. C sharp, 554. Okay, then we have 140. B, 494. 420, A, 440, $140, B, that's 494, $420, A, it's 440. And then we have our rest, 70, 30,000. Okay, let's get some data statements going here. So 420, 440, 280, 659, 420, 659, 140, 554, 140, 587, 140, 659, 560, 587, 420, 554, 140. I'm going to see how long I can go here. 587, 140, 659, 140, 587, 140, comma 554, comma 140, comma 494, oops, comma 420, 440, 140, comma 494, comma 420, comma 440, comma, oh, not quite going to fit. Line too long. Okay, yeah, that's what I was worried about. So, new. I'll just do one line at a time here. It's all good. 420, 440, 280, 659, 420, 659, 140, 554, 20, data, 140, oops, 587, 140, 659, 560, 587, 420, 554, 140, 587, 140, 659, 140, 587, 140, 554. Data. I wish there were a way around some of this, you know?
Yeah.
Come on, 140, 494, 420, 440, 70, 30,000. All right, that didn't take too much information. Okay, 100. Restore to line 10. 110 for music equals 1, 2. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Just double check. 17, including the rest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, plus a rest. Perfect. Like when things add up.
Same.
Read duration du fr 130. Call sound, duration, frequency, and let's get this volume way down to like soft. Let's see how it sounds. 140, and I'll turn my computer up to where it normally is. Okay. 140, next MU. 150, go to 100. Let's see how we do. It almost sounds like Star Wars.
It does.
Sounds pretty good though, doesn't it?
It does. I like it.
I like it too. Let's consolidate some of these lines. For MU equals 1 to 17, read du fr, call sound, du fr 20, next MU, go to 100. Everything on one line.
Nice.
I'm feeling optimistic here.
Yeah, that one's a lot shorter than what I had done earlier.
Yep, so let's get rid of, let's see, we're in our, yeah, okay. Let's get rid of this. Let's get rid of this. This is in our playground here. Okay. So everything else is going to be the same, except we're not going to play, well, yeah, it's okay. Okay, hold on. That's looking for input. So this go sub is going to need to have to go in. This searching for input go sub 6900 is going to have to be in between each note. That way, whenever you press the key, it skips ahead. So I want to try something here. I want to see what happens when we insert a call key statement in between call key 0, K, S. Oop. Forgot the two colons. Sounds fine. Don't even notice it.
Yeah. Doesn't seem like it did anything.
No, it sounds good. Okay, so what we want to do then I'm going to try to do this so we draw the background, we go to this data statement, start drawing things. Eventually we draw the press any key. Okay. And then right after that, we come down here to 6460, more data statements. Here comes our data statements. 420, 440, 280, 659, 420, 659, 140, 554, actually, we'll probably do twice as many there. 140, 587, 140, 659, 560, 587, 420, 554, that'll probably be fine. 6470 data, 140, 587, 140, 659, 140, 587, 140, 554, 140, 494, 420, 440, 140, 494, 420, 440. I'm going to try to squeeze this last one in here. 70, 30,000. Let's paste these in and see if we get line length errors. No, that's good. All right, that's good.
Nice.
6480. For mu equals 1 to 17, we said.
Yep.
Read duration and frequency. Play the note. Call sound. Duration, frequency, nice and soft, 20 for now. Okay. Go sub 6900. Here it's going to be a little different. Oh, actually, we need to probably go on to the next line. 6490. If S is not equal to 0, or H is not equal to 0, or V is not equal to 0. Because what we don't want it to hold it. We want it to move on. If we press a button, we move on. So right now we've got it holding if everything is equal to 0. Now we want to tell it to move on if anything is not equal to 0. Then return. Else no. 6500. It's only going to return if it gets anything, and then we do next. MU. Boy, is that it? We have to renumber these a little bit because we're overlapping with the next.
Yeah.
So 6460, 6465, 6470, 6480, 6490. that literally everything? Let's save, hold on, 64, 60, 64, 70, save DSK2, say ecolos 2. That way we have that. Let's paste in our program. We can paste in this new version of that. We'll paste this in first, then we'll paste over it. We'll paste in this new title screen routine and see whether it fits first of all and how it sounds second of all.
Hey,
It's not too bad. We're getting it in there. It sounds pretty good. I can live with it.
yeah, I like that a lot more.
It's ancient. It's ancient Greek. You know, I like it.
Yeah, it's got the right vibe. It sounds good.
Yeah, and we could actually tweak with the frequencies a little bit to make it not sound quite so modern. You know, we'd use an older tuning, drop it down to 432 maybe, just to, you know, I have a thing to calculate the frequencies. So
Yeah, that'll be cool. I think that would sound really cool.
who knows what they used as their basis? You know, I don't think they have any real idea of what a standard tuning was back then. This is all just speculation in terms of, you know, they've got the notes in relation to each other because they actually have ancient Greek music for this piece of music on a piece of wood, I believe, and but they don't know what exact frequencies were being used. I'm pretty sure. So how are we doing on size? Oh my God, look at that. Okay, let's paste in this new version of this. Just these lines, right?
Oh yeah.
Oh wait, no. Yeah. Because we insert, okay, size. That's right. I'm just curious what happens.
Mm-hmm.
So we need to loop it.
Yeah. 83 bytes left.
Okay, so rather than mess with it too much, so what do we need to do here? We need to loop this now. So 6495 go to. We need to loop back to. Oh, we didn't have the restore. Okay, hold on here. I forgot. Restore. $64.60. And this needs to go to $64.70. Let's paste this in. And let's turn off the throttling for the moment.
Yeah.
We might want the final the walking sound effect. Maybe we want that not to be there actually.
Now that there's music, yeah.
Mm-hmm.
Maybe it doesn't need to loop.
At least it worked.
It did. Yeah, maybe we could take out that last sh and just have the music start there, and maybe it doesn't need to loop. Maybe it can just play one time and then you can go on to this next screen. It does sound pretty alright, but I feel like there's like too much of a gap in the loop there where it loops.
Yeah, but that there's no way around that because it's got to do two things. It's got to, I think there's no way around it. I think this is why it's going to be great when it's compiled. I think because we're getting the key input here, and that's not what's slowing it down. It's this that's slowing it down, this if-then statement. It's really... actually, hold on. I got a better idea here. I want to... Hold on, let me try another version of this here. Let's comment these out. Anything I can do to tighten it up, I think will help, you know? Okay, so 6480. If S equals 0 or H equals 0 or V equals 0, then next mu. I don't know if this, it might, this may not be syntactically valid, else return. $64.90 go to $64.70. Okay, hold on here. 64.80, 64.90, and 64.95. Now paste these new ones in. I think this might work. It might not like this next end, the next statement being after the then. I'm not sure. Yeah, I didn't like that. That's what I was worried about. Okay. Nice try. All right, let me think. How can I tighten this up? Oh, wait a minute. 6495, that go away. Let's paste both of these in. I'm going to speed it up a bit just to check to make sure it's working. Sounds really good. I like it when it's fast.
It does.
I mean, it works fine. That's what it's going to be like when it's assembled. Sounds good.
Yeah. I'm glad we tried that sound. That sounds way better.
Let's see what Unfortunately, I think there might just be a little gap in the, the music on the uncompiled version. But insofar as we're going to make a cartridge out of it,
Yeah, that'll just be a character of the game. Yeah, I do feel like it could just play once instead of looping.
Well, let's but then if we don't loop it, I mean, maybe we don't even need press any key. Maybe we just, you know, play it the music and then you're into the into the game.
Could definitely do that too. Or it could just, yeah, do the sound effects there, play the music, and the press any key is there when the music, right before the music starts, maybe like that appears, and you could just skip the music if you wanted, or listen through it, unless you're not
I
allowed
don't
to
know.
say while you.
I think it needs to go either way. I think if we just play the music, then that's the pause we need. We don't even need to press any key, right?
That's true, yeah, and yeah, we don't have to necessarily declare that's how you get to the next screen. It
We
could just not be there.
Right. Okay, so let's do a little surgery here. If we're not going to loop it, we don't need this. Okay, let me think now. We don't need this. And we don't need this. We still need the return. Except 6480 next mu, and then we're going to return after the loop ends. So we're not going to draw press any key, right?
Sure, yeah, we can try that. I think we should keep those numbers or something.
Yeah. Well, we've got them in the other version right now. This is just our sandbox
Oh
here.
yeah, that's right. That's right. You're right. Yeah, take it out for a second. Let's see.
Which is easy to do because we can just comment out everything here. Oh, wait a minute. No, wait, hold on. No, hold on. One, 2, 3, 4, 5, 6. Okay, that's why we have 6 here. Yeah, so we can get rid of this. Yeah. We'll still have that pause. But if we're not, you know, we could bump this up to the top of the game. This bit right here.
Yeah, I think that's what we should do. Yeah, that what was it called?
Yeah, well, the dimension statement's already up. This is actually assigning values to each spot in the array.
Oh, okay, the dimension's already at the top now.
Yeah, but this, so we could put this immediately after the dimension statement up top, which is good because we can smooth out our line numbers here as well. Okay, so I think this will do it. So what I want to do, just to keep things clean, let's get a fresh paste of our official version of the game here. We'll paste this on top of it. We might need to adjust the positioning of some of the things on the screen now, if we like it. Because
Yeah.
although maybe not. You know, maybe just bump the copyright line down to the bottom or something.
Yeah.
Maybe the other lines can go down by 1. Who knows? I'm up to this. I think this will be good because I think it solves the problem of the weird choppy music. It solves the problem of the delay.
Mm-hmm.
Gives you a little pause anyway to play the little do 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 do, and then you're in the game. Boom.
Yeah. Oh yeah, so this one you won't need to press a button. It'll just, once the music ends, it'll throw you in the game now.
Exactly. If I've done my job right in these new lines. I think that'll be okay.
Yeah, that should be okay. Turn on the game, you're normally ready to play when you turn it on.
Yeah, right, exactly.
And even if you got put into the game right away at that start screen in Socrates' house, you can just stand there as long as you want.
So we're going to paste all of this in. Pretty good. We're okay in size-wise, I think.
Mm-hmm.
I forget whether I had this CPU throttling on or not. Why did we not get our little sound effects? Oh,
Yeah,
because that's not part of this. Yeah. So where's the loop here? It was go sub 6700, right, for the sound effect.
I don't recall. Sounds right though. I'm not certain.
I think it was right here. Let's paste this back in. I'm almost certain it was this line.
Nice. Yeah, we just put that delay or that gap there at the beginning instead of here.
Yeah, so let me do a couple things here. Let's save the save. Let's go to my title. Oop. Oh, come on. There we go. Title screen sandbox. Save that. This we already have saved. Let's close that and close that. And okay. I know this is a little silly, but I want to work on a copy. We're making fairly significant changes, you know?
Yeah.
Okay, now I got a fresh copy here that I can work in. Open. Let's get our sandbox. Okay, let's do some surgery here. So we do the dimensioning right here. So what we'll do is on the next line, we'll add a line 9. And let's go grab our this stuff. All of this. is now going to go right here. And what was go sub 6400? What was that for? Oh, that's the title screen. Okay, yeah. So then we draw the title screen, then we move on. Okay. Nice. Okay, then we come over here. So all of this is going to go away. Let's comment it out. Okay. Let's paste it in and see how we did.
Yes.
And then we'll look for ways to consolidate a little bit more. So it'll take a much longer pause at the beginning, but who cares, you know, frankly.
Yeah. Yeah.
The only reason we put it down there was to create the pause.
Yeah, just because it's like, oh, we already have this, and yeah, it wouldn't hurt to have a little delay before this button appears, so let's use it like that. But yeah, just throw it in the beginning and have the music, and there'll be better.
Well, that's pasting. I want to look at something. Probably get rid of this if we're not going to use it, this extra piece of data here. Great, I'm all about trimming things out.
Trim it up.
Hello to everybody tuning in. I see folks tuning in. Been at it for a while here and trying to squeeze in some title screen music to our Socrates game in TI Extended Basic. We are very near the memory limit, even with the 32K memory expansion. So let's check our size. I think we'll be safe.
Yep, looks like it.
And then the CPU throttling is off, right?
I think so.
Why are we still getting press any key?
Oh yeah, did you delete that from the actual version? Or just play for Sandpit, I mean.
Yeah, let's see here. What's happening? Oh, it's right here, right? Because
Still right there. Yeah, I think you took it out of the playground or the Sandpit version, but not this.
so, well, this can go away, right? Because this is just displaying the press any key.
Yeah.
This loop here, yeah, we'll clean this up. But this loop here is reading 6 pieces of data. So 1, 2, 3, 4, 5, 6, and then the 7th piece of data is being read right here.
Yeah.
So this can go away.
Yeah.
And this can go away.
Yeah.
These can be renumbered. Except this needs to start with the music, which is 6450. Like that. Okay, let's paste this in. 64
I feel
not.
like the Spark Gap games, wouldn't that fit on the same line as the rest of them? As the Dylan?
Oh yeah, definitely. Yeah. Let's do that. Right, definitely.
Yeah. Oh yeah, it's because you took off the other ones. Yeah,
Right.
so it got shorter.
Like so.
Yeah.
Yeah, anything we can cut out, so much the better.
Exactly. Nice.
This needs to be restore 6440 though. Save. Okay, so now we got rid of a couple lines, 6480 and 6490. So 6480, 6490 are gone. We'll paste in the new version of this. Better.
Nice.
And I think we'll need to adjust the spacing of everything else on the title screen a bit.
Mm-hmm. Oh yeah, it's doing the.
You know, I think we need to bump that up.
Yeah. Yeah, don't let it draw anything first.
I like it.
Want like a little delay at the end there, just like give you like a second or two.
Oh, sure, that's easy. But let's do a little surgery here on the order of operations.
Yeah.
Let's do this. Before we do anything, let's call clear.
Yeah.
Let's do it here. Don't you think?
Yeah.
Okay. Before we even change the screen color, right? Or maybe after we change the screen color. No, before we change the screen color. So it just seems like it's just processing.
Yeah, exactly.
Actually, I actually have an idea about that. Let's get an extra line in here. We'll renumber everything in a second. So we'll clear the screen. We'll do this dimension right here. Then we'll do our loop, this stuff, right?
Yeah.
And actually, before we do anything, why don't we do display at, I don't know, for now, let's just put it at 15, comma 15. I don't know, like 4, comma 4. Is that you, Brad? Are you Retro TI-99 4A? Yes, the key scan routine is much better. Yes, thank you. Cleaned it up a lot. It runs a little bit faster, yeah, and that's you. Hello. I wasn't sure if 100% if that was you, but I figured it might be. Nice to meet you finally. I think, why don't we do something like this?
Oh, yeah.
That way it clears the screen, says loading, so you know something's happening. You know?
Yeah.
Then we do the dimension and the array, which is going to take a minute.
Yeah. Takes like 5 to 7 seconds or something.
Yep, and then we clear the screen again. After that's done, we clear the screen.
Yeah.
And then we move on with the rest of our stuff here.
Nice, I like it.
And these can probably fit up here, right?
Oh, yeah.
You know, actually, it makes me think. a lot of this variable assignment stuff, why don't we just put that on the loading screen? Why are we doing that after we've already cleared the screen and stuff? You know what I mean?
Oh, yeah.
So why don't we take all this gobbledygook? And all of this gobbledygook. What's 6,500? I forget what we did there. 6,500. Oh, yeah, okay. It's just calculation that we're reusing a couple times. So all of this, if we can fit it on there, may not fit. It might fit, actually.
Nice. Yeah, I think it does.
Yep. Let's just kind of create a new version of this. All of this. All of this. Thanks for tuning in, Brad. It's I do appreciate. I worry that it doesn't come across that I appreciate all the advice. I've been hesitant to try a different code editor just because I'm already in a rhythm on this one, and I do want to try it. But I really appreciate your willingness to jump in and show us how to compile, because I've never done that before. So.
Yeah, that's super awesome.
Okay, so this is 6,400. That's the title screen. And this is what moves us on. So we want to do all of this next. Yeah, so this can be on its own. This is going to be too long, I think, but maybe not. It may just squeeze in there. We'll see. I think that's everything. So let's paste this in and see how we did. Actually, you'll list 1 through 10. Just want to make sure we don't have the line number 10 in there. Okay, we're good. Somehow we're getting it in there. Music and all. We got music now.
Let's go.
Based on the Saikilos epitaph, the oldest known piece of written Greek music. So we'll adjust the position. Loading. Maybe we can create a cute little routine so those dots.
Oh,
or
that'd be cool.
Maybe the whole thing can repeat until it's done.
Yeah, that'd be cool. Spacing there actually looks pretty alright. Nice.
Let's put the CPU throttling on. Maybe it's a little soft now. You're right, it needs a little delay, doesn't it?
Yeah, if it had just like a couple seconds after it finished, like 1 or 2 seconds.
That's the kind of thing we'll have to adjust, of course, based on when we compile it. We'll have to just see how it feels.
Yeah, for sure.
Okay, so you can only just barely hear the music. Interesting. We've got the volume set quite low. For me, it sounds quite rather loud because my volume is turned up a bit. I agree that it's a little soft. So right here, wherever it is, that's down here, right? 6,400. We need to adjust the volume. Maybe put it at 10 instead of 20. We want it to be a little soft. We don't want it to come in booming. Maybe we do. Let people control their own volume. Who cares? We just want it to be balanced in terms of its relation to the other sound effects in the game.
Yeah.
So let's paste this line back in. It didn't feel terrible.
Mm-mm.
But you're right, it needs a little delay. So here, before the return statement, we want a delay, right?
Yeah.
For, I guess we can probably use the same variable actually for mu equals. Again, it's gonna be weird because there's no right answer here. You know, if we time it for the compiled or the throttled version, it's gonna feel really slow for the for the unthrottled version, and if we time it for the unthrottled version, it's gonna blaze right over it in the throttled version. So they'll just have to. I maintain that we'll probably need two versions of the game. We'll have the version we put on the cartridge, and the assembled version, and then we'll have the physical version, but also have the digital versions, and we'll have two digital versions. We'll have the digital version that's been timed for, just regular old extended basic, the best we can do it, and the assembled version that's a digital version available as well. So all that to say, I don't really know what number to plug in here. Let's go, I don't know, 100. I have no idea. Okay, this will add a little bit of a delay. I have no idea what it's going to feel like with the throttling going on. I have some sense of how the it's not long enough, is it?
Mm-mm.
I mean, more and more we're playing it with the throttle on, because we know we're going to compile it anyway. So.
Mm-hmm.
Still not long enough, is it?
Didn't feel like it. Yeah, it still feels kind of short.
I'm glad you like the startup music. We've tried many things, both behind the scenes and on the stream. I can't take credit for it. It's, some ancient Greek composer wrote most of it. We did do some tweaks on the timing to get it to sound like we wanted it to sound. I'll show you the, in fact, I'll paste a link to it here in a minute. Yeah, that was better.
Yeah, that was good.
Do-do-do-do-do-do. And then just one more beat, and there it is,
Yeah, exactly. Yeah, just needed another second.
Actually, the only other thing we can do is into our call sound routine. All we need to do is increase the length of this rest at the end, because we're not looping back.
Oh yeah.
And that we can control.
Yeah.
Let's do that, because that's going to sound the same in the throttled and the unthrottled version.
Yeah, and be shorter.
Yeah, and we already have a number for it here. All we have to do is change this number. So let's see. Let's go back and look at the music here. So 420 was a dotted quarter note. So we end on a dotted quarter note, right? Yeah. So why don't we do another... Because it had the delay there. Let's try this. That'll work better. Hey, we might need to adjust it a little bit, but at least we can control it now. Nope, actually it needs to be a regular quarter note. It's too long now. Let's try 280. Just needs to be like one beat.
Yeah.
Oh, hello. Oh, yeah, let me grab the music. This is the Saiklos Epitaph, if you want to read up on it, the oldest known piece of ancient Greek music in written form. There's a picture of its inscription here. There you go. This is where it's from. It has words and music notation, ancient Greek music notation on it. Very handy find.
So cool.
Yeah, very cool. I love it. The timing feels pretty good.
Yeah.
Let's turn the throttling off. It is very cool. You know, I'm not an archaeologist, but I do have an amateur interest in archaeology. So, you know, anything like that we can put in something that's real into the game is great. And it's amazing that things like that survive. And, you know, that's the thing about archaeology. There are finds all the time. Just when you think there's nothing left to be found. I mean, even as recently as a little over 100 years ago, they had a lost manuscript from Aristotle that was found in the desert in a pot. You know? Yeah, it's just like one of his missing works was found. You know,
That's awesome.
so things are constantly being found. It's really, really interesting if you're interested in ancient things like I am. Okay, so this should be the unthrottled version. We'll see how this feels.
Nice.
Yeah, as you can see, the actually, wait a minute. Hold on here. We don't even. Why is there such a delay? Hold on. I need to look at something.
Figured.
Yeah, why is there a delay? Because we took out the delay, so why is there a delay?
Didn't you make the rest longer?
Yeah, but not by much.
Mm.
So why is it so much slower? Shouldn't be. Okay, let me run it again, see if I can figure out what's going on. I mean, it's fine, you know. The uncompiled version is going to be slow. I don't think we need to apologize for it. Anyone who's going to load it up in the uncompiled version is going to know what they're going to get. It's going to be a little slow.
Yep.
I don't think that's going to surprise anyone who's going to mess with this. All 100 people on the planet who are going to check this game out, you know. Okay, why is there such a delay there?
Yeah, it's probably almost 3 times longer than we want.
Yeah, hold on. I know this is gonna slow it down a little bit, but I want to see what's happening here.
Yeah.
It's doing all this stuff with the array. Okay, that's weird. Why? It's just sitting there. Why is it doing that?
6470.
Oh, because I didn't paste this back in. Hold on. Hello, this is why.
Oh, yeah.
I deleted it, but I didn't paste it back in.
There it is. Nice.
Which means I also need to retest it on the throttled version.
Mm-hmm.
And Brad, you said that the assembled version is going to run a little faster than the throttled version here in Classic 99. Am I remembering that correctly? I guess that felt pretty good.
Good. Is this a slow version?
Yes. We're going to check out the fast version right now. Felt just a little fast, but it felt pretty good on both. I think we should speed it up a little bit for the, or slow it down just a little bit for the throttled version. What do you think?
I agree. Can we see it with the non-throttled version again?
Sure.
I felt like maybe it needed a little bit more delay too, just a tad bit.
Dylan is not keeping an eye on the chat, but Brad has confirmed that the assembled version will run a little bit faster than the throttled version in his experience.
Nice. Cool. That's crazy. It really speeds it up.
Well, it's a really fast system. The problem is not the system. The processor is really fast. It's the version of BASIC that runs basically in VDP memory. So it's an interpreted BASIC that is just runs line by line by line by line. The processor is really fast. You know, the stuff written in assembly for the processor zip right along. I think the timing on that felt great.
I wanted to have this, I don't know, it's like so good that the beat happens at the time I want. I think it is pretty good.
But there's not enough of a pause in the throttled version.
Yeah, the throttle version goes too fast still. Feels
Right,
like.
so I think what we should do is adjust this number right here. And let's go back to trying that dotted quarter note, 420. I can't believe you got the music in there. I was really worried about that.
I really like the music in there too.
My sister will get a kick out of that because she's the one who turned me on to this little piece of music anyway.
Oh, cool.
She's a music teacher, so I asked her, like, hey, you got any suggestions? And she said, oh, here's a piece you might consider. So thanks to my sister. I'm glad you like the music. It's I love it.
Nice. There it goes.
Oh, that's the normal version. Let's put the overdrive on. Might need to just lengthen it a little bit more. You think it's still a little too fast?
Potentially, but maybe we could just slow it down on the compiled version. Because
what if we try this? Also, I was thinking at the beginning, before the music starts, after we hit the last little from the text going on the screen, we could add another line to this data statement here and add a rest at the beginning to have a little pause at the very beginning as well. What do you think?
Before it starts the music?
Mm-hmm.
Can we hear it again? Or
yeah, let me lengthen this because I think this will sound just a hair better. After the last line of text goes on the screen, I think it needs a little pause. But tell me what you think.
Yeah. The American bathroom version. Yeah.
Oh, that feels pretty good.
Yeah, I could see it having a gap at the beginning.
So what we could do, we could actually add in something. We can adjust the timing here in a minute, but let's do 560, 30,000. And then this will be, rather than 1 to 17, 1 to 18.
Nice.
And that will give us a pause at the beginning, and one we can control pretty reliably. I never thought of using call sound statements as a reliable pause, but works pretty well.
Nice.
Let's try that again. I think that feels better.
It does.
Anyway,
Outro still feels quick there,
well,
but I don't think it does normal version.
so you cut out just a little bit. What feels quick?
That after the song transition still feels a little quick, but I think it feels good in the normal version.
Oh well, I mean, let's do a couple things. Let's check the unthrottled version real quick.
Yeah.
You know, we gotta come up with something that works for both. You know, if we can, that'd be great.
Mm-hmm.
You know, no one's actually going to buy this game. Someone might. Never know.
Yeah, and it might not be right away. It might be later once we start getting more traction with other games.
Mm-hmm.
We might start finding out about this game and come back to it.
That feels perfect.
Yeah, that felt good. I think that the beginning gap might have been a little long. Can we run it one more time?
Sure.
In the slow down version.
I don't.
Maybe not.
I don't think I didn't jump out at me. I liked it actually. Give you just a second to read the text. You know.
Yeah, that's true.
Before you're on to the next thing. I think we can probably change the screen color there so it shows that you're in the program already. I think it felt fine.
Yeah, that feels good. Let's leave it like that.
Okay.
And see if we want to change it next time.
Let's go up here and
Back.
it's feeling pretty good. I want to try something real quick. I don't think we need this call screen statement here now. You there, Dylan? Ooh, 118 bytes free.
Okay, I'm back.
A happy accident is that the beep that happens when the room generates is the same tone, is the same frequency as the last note of the song. Happily.
Oh, nice.
Yeah, we just did that totally by accident. You know, we just grabbed A 440 for that note. So it sounds like
Oh,
do 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 do. Sounds like part of the song.
it feels really good with it. Yeah, I've been thinking that last beep
Yeah.
finishes it off.
So much so, I think we'll just leave the frequencies as they are. I was going to mess with them, but I think they're fine.
Yeah, I like it. I like the way it's sounding.
All right.
Fit.
Let's go down here and look at our new code. Is there anything we can do to consolidate this? Yes, I think we can move these lines up here. Let's comment this out. $64.70 is going to go away. And let's paste this in. It's amazing how much real estate we've managed to get back by tweaking and tweaking and tweaking and consolidating. You know?
It is. Every time we're like, oh my gosh, we're like on the fence, we end up finding a few more bytes, and we've added in so many things with it.
Mm-hmm.
We keep finding something where like, oh my gosh, we want to add this, but I don't think it'll fit, and then we find a way to where it just like barely makes a difference to add it in. But we end up getting space back somehow adding it in. Nice. Nice.
Okay. Yeah, nice indeed. Okay, I'm satisfied that we can get rid of this. How about you?
Yeah.
This is in my copy, of course, so it's fine. Let's see. We need to adjust the positioning of the. We don't need what? Sorry. This line.
We don't need that. 6470. Yeah.
Yep. We need to adjust the positioning of loading.
Oh yeah.
Unfortunately, there's no way for it to know. I was suggesting maybe having a little loop that animates the dots. Maybe there's no way for it to know when it's done doing everything else. So what we could do though is we could do it once, loading ...
Yeah.
Or even better, what if we did? I have an idea here. How many characters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's use the same loop variable we've been using. It's fine. Use 1 to 10. Call HCHAR. Let's see. Let's do it at row 12, comma. Okay, now we need to do a little math. We have 32 characters minus 10 is 22. Divided by 2 is 11. Plus 1 is 12. So 12. No, it'll be 11 plus mu. Oh, wait a minute. We need to do the string segment routine. Oh yeah, that's right. Let's see. We can grab the string segment code down here. I always forget the syntax for that damn thing. Where are you? Where's that string segment stuff? What is that? Okay, hold on. Oh yeah, it's just, that just means one. I got it. Okay. String segment of. I think it. I don't remember if it has to be in quotes or not. I think so. I might have blown this up, but let's try it. Or I just used up all the remaining memory.
Yeah, every time we add anything, I'm nervous about that.
Add value in one. Oh, I know what I did. Maybe. Yep. String number mismatch in one. String number mismatch. Let's go to the manual. We want the string segment. Growing up, I just never used some of these commands. I didn't know enough about programming to know what the hell they meant even, back in the day.
Yeah.
So I always ignored them. Okay, string segment. Okay, why are we getting a string number mismatch? Oops. Do you see what's wrong here?
Not so far.
So this is row, column. Oh, wait, hold on here. Yeah, there's a problem here. Right, that's it. You need the ASCII code. Thank you. I knew I was missing something. Right, we don't need the string segment itself. We need the ASCII code for the string segment for that. It's basically grabbing one letter at a time. We don't need the letter because the call CHAR statement, you use row, column, and the ASCII code for the character you want. So we're grabbing the string segment one character at a time based on where we are in the loop. But we need the ASCII version of that character. Okay, this should do it. It's like duh. I've only been doing this since I was a kid. I should have saw that. This should work. Assuming we have enough memory. Hi, Dinah. Would be a Twitch cat. You're famous, see? You're famous. Oh, that was better.
Nice. I like it there in the center. Oh yeah, and it's with the white instead of blue.
Or gray, yeah.
Yeah, or gray. Yeah.
I mean, I could make it white. I just thought gray would... Maybe it should be white.
Yeah,
I don't know.
or the green. Go back to the classic.
No. Let's show we're just in the program already, you know? We're not using that green for anything else.
That's true.
How much memory do we have left? 82 bytes.
Nice. Okay. Okay. And the music's in.
And actually, here we can use any variable we want because these are all being assigned later. So this, since insofar as this loop starts, we can just do, maybe we can just do m, because m gets reassigned later anyway, and we never circle back to this, so we'll never get an error. Just double check. It's unlikely it will mess up the movement routine because the moment we're in the movement routine, we grab the inputs and then overwrite the variable m.
Nice. Looks so centered.
Mental math.
Nice. So that all felt pretty smooth.
Yep, no problem. No problem there at all. I don't know, I was thinking we could do... What was that sound effect? Ghost 6700? Call sound? Hold on.
Nice.
Might as well reuse as much as we can, you know?
Yeah.
See what you think.
Oh, nice.
Didn't sound right, though.
Can we do the typing sound instead of the walking sound?
Oh, yeah, maybe that's the problem, right? I'm using the wrong sound. Yeah, that's exactly the problem. Okay, the typing sound is where? That's why it didn't sound right.
It's near the other one, I think. The 6900? Oh, no, it's not.
That's right. Let's just find our typing routine here.
Yeah.
10,000, I think.
There it is. You call sound at 10,000.
I know, Dinah. I'll let you out in a minute. One thing we're missing, though, is the delay. Because in the typing routine, we have the little 8-count delay in there, which is fine. Might not even be necessary, but so far as we're going to speed things up anyway. could do here. I know this is. Actually, I can do this. Oh, it's 3, 4, 5, 6, 7, 8, 9, 10. This will feel a little more familiar.
Nice.
And in the faster version, there we go.
Nice.
I like it.
Nice.
It feels pretty good.
It does. It's awesome.
And a whopping
Yeah,
62
really.
bytes left.
It's getting low.
It is.
Yeah, I really like that music. It's really, really
Yeah,
nice.
it's grown on me the more I've played it.
Yeah, same. And that loading screen is actually pretty cool. I like that.
This delay, insofar as we're using it a couple times, we could make a little subroutine out of that delay. Well, let's save this. Let's look at our Trello board. We have added title screen music. I'm not convinced we're gonna have room to get a jury in there. Maybe.
Yeah, or other extra sprites probably.
New corner door tiles. I'm thinking not.
Probably not in this version of the game.
Yeah. Sound effect for the exclamation mark. We did that.
That would be really cool.
Oh, you mean a different sound effect?
Yeah, we're talking creating a unique one.
Yeah, let's think about that for next time.
Okay.
Extra NPCs. Still maybe a nice to have. I don't think we're going to do the roads and pathway thing.
No.
Nope, not going to do that.
Version.
Not going to do that. Not going to do that.
Nope, not in this version.
I think that's a nice to have.
Yeah, out of all those things, the exclamation mark sound effect sounds the coolest to me.
Mm-hmm.
NPCs would be cool too, but it'd be better if we could put them in more sporadic and not just in like a couple rooms, but yeah, more generously.
Yeah, so we've got this little 8 count delay several times.
Yeah, we could make a sub. How many times?
It's here, it's here, it's here.
Oh, yeah, let's make one. That's already 3, and there's one up. Yeah, that's at least 4 or 5 of them.
just do DE.
Nice.
So go sub 16,000.
Yeah.
Okay, anywhere we have a 8 count delay here. Right here.
Yeah.
Oops. Wrong button. Go sub 16,000.
Nice.
Okay, let's go looking for 8 count delays. Mainly in our typing routine, right? Right here.
Yep, there's one.
Right here.
Yep.
And right here.
Yep.
That's it, right?
Yeah, there shouldn't be any down here. Oh, never mind. The subroutine itself tricked me for a second.
Let's paste the whole thing in, make sure we didn't blow anything up.
Yeah.
Dang. And then we'll call it night, and I'm gonna go get some dinner after this.
Nice. Okay.
You're okay, Dinah. Looks fine.
Nice.
I think it looks fine.
Same.
Well, pretty darn good.
Agreed. Yeah, the music turned out really nice.
87 bytes free. Got a few bytes back from that. Yeah, music turned out good. I'm happy with it.
Same.
Let's save our work here. Let's. Oh, did you want to? We can do it next time. Let's make a task for next time. I gotta get dinner. It's getting late. Adjust position. Adjust position of text on title screen. I think we need to bump everything down by 1 line, probably.
I was thinking that earlier just a minute ago too.
Yep.
Socrates is probably fine, but yeah, I think our names and stuff, everything else should go down at least 1. Yeah.
There we go. We'll do that first thing next time. That'll be easy. Let's save our work here.
Good job today.
Yeah, we got music in there.
Yeah, that music pretty awesome. That was fun to mess with.
Alrighty. Well, Brad, if you're still watching, thank you for the help and tuning in. Dylan, good work today. I'm up for Thursday if you are.
Yep.
Yeah,
do it.
same time, same place, same channel. And yeah, until then. Oh yeah, we're just wrapping it up. So
I'm getting the veggie place.
I'll see you in 1 minute.
I love you.
I love you too. Yeah, good work. Let's get a screenshot here, actually, of something. I'm not sure what to get a screenshot of. We really didn't change very much, did we?
Yeah, the loading screen.
Yeah, no.
We changed the effect, and the exclamation mark is pretty much.
Yeah, let's get a screen. Yeah, I get a screenshot of that. Why not? Screenshot. Oop, actually, hold on. I want to get a screenshot of the loading screen. I'm just never sure what screenshot I'm going to use for the.
Screenshot of the music.
There we go.
Yeah.
There we go. Good enough. Alrighty. Brad, have a good evening. Dylan, have a good evening. I'm gonna go get some dinner. I'm starving.
Enjoy your dinner.
Thanks. Really good work today. We did good work. Thank you, Brad. We did really good work on the music. I'm so stoked we got it in there.
That was like one shot. We knocked it out today.
We did. Good.
We can't fit it. The first few things we tried were too big. We couldn't fit them.
Mm-hmm.
Song that we made fits. That's so cool.
It is very cool. That's what you got to do. You can't just go with the first thing. You got to try things and try things and try things and go, okay, none of that's working. Let's get back to basics here. Yep.
Exactly. Exactamundo.
I will catch you Thursday. If not before, I'll send you any ideas I have as usual. So.
Perfect. Love it.
Have a good night, all. Thanks for watching, Brad. Good night.
Bye.
Bye.